All right, so I see about that much. So if I go to pop out the chat, well, then it just leaves a stupid window there, doesn't it? Right? What an incredibly dumbass design. It's one of those things that like it makes me annoyed because whoever designed that is an idiot. Okay, I'm sorry to say this, but if you're watching this and you work for YouTube, I'm sorry I called you an idiot. Okay, that was uncalled for, but it's still really dumb, right? Hello, Alcrust, how you doing? All right. I had such a wholesome comment on YouTube this morning. It was really nice to see that. Not one of those like ooh comments. You know the what I mean, right? The ooh comments, right? That was just so nice to see that, right? It's like YouTube comments and someone's not being a dick. How did that happen, right? Anyway, so what are we doing? I have too many fun projects going on, right? This morning. But this morning wasn't for me. This morning was purely for Enrico, who then proceeded to complain that the stream wasn't live when I spent all morning recording really shit footage, right? That's a good point, Chris. Yeah, you know what? I never use split view because I got split windows instead, but I probably should use split view, right? Enrico, I wasn't being serious, buddy. Okay, listen. I might be one of the biggest douchebags in the world, right? I'm sure it's dressed like one today, but I try not to be. Okay, a lot of the times it's just for shits and giggles, right? I just feel like I need to make that clear so you don't think that I'm actually, harboring ill will towards you. All right, let's see. Where are we? Here. It's multiplayer time. There we go. To me, it would be this space here that might disappear. I don't know what Firefox will add in between, though, right? That video is probably not in full HD though, Enrico, but it's there. It is me building something. So what happened, right? What happened was I did everything. I mixed the coin. So the attempt today was to put some hello runtime. How you going, buddy? The attempt today was to put some pigments, some paint or whatever, right? So I dug out some old acrylic paints to try to play around with that and see if that had any impact. I can tell you that it did not, right? You definitely need something stronger than what I had, right? Hello, Scott. How you going? What happened was so I poured a thing, and as I did that, I realized that I forgot to put any kind of release agent in there, which is why I emptied it and did went again, right? And this is normally not how I do it, though, Enrico. I usually use a piping bag for this. It's a lot smoother than that. So I'd have a piping bag, but I did something with the last one, not this one, the last bowl I made, which is actually in the video, but it's unfinished, right? So that bowl, I poured all the concrete, then I added a top on there, all right? So that was really easy to pour, but I usually use a bag. I mix everything in a plastic bag, cut the edge off, and then use it as a piping bag. But now I was outside and not in the workshop, which is, I finished it in the workshop, right? But that was my morning anyway. Yeah, so today we're doing multiplayer stuff, and that's gonna be fun for me, maybe. I don't know about you, but it'll be something for me, and I'm kind of excited about that, right? Where did we leave off? Multipants. We're gonna look at the server first. We're gonna find out where this thing is crashing. This ill-willing bastard is crashing somewhere, right? We're gonna unwrap everything. No error handling of any kind, because we want to see where the crash is. Okay. Okay, so we can't search for that. Not like that. Okay, on webs. No, so what you do, Enrico, is you make it and then you melt some wax and add a wick to it. The question is, should I bother with that? Because this was such a nonsensical thing to do. But I have an old Yankee candle that is just sitting around collecting dust and looks a little bit rough. So I'm thinking I might use that one. Just use it as a double boiler to melt the wax and see if I can save the wick. Maybe, but let's not assume that's what we're gonna do. Okay, let's have a look at this stuff now. We are looking for question marks. We are getting rid of question marks. Hello, Gree, how you doing? Okay, no question marks there. What about here? Oh man, can you just not? Whoops. Whew. Struggling to type today, apparently. Well, I can't answer for anyone else, accordingly, but they are all doing well. I have decided. How you doing? Are you excited about summer? It is so much summer right now. I got summer all over the place now. Okay, I think that we are done with the question marks now. So let's see where this fails. I suspect that this is failing because of that we just exit a loop that we shouldn't exit. So let's just see what happens here. We sure are sending stuff, so that's it. Best game in the world. Okay, but it's not crashing. Quite a low there. Oh, I don't like the sound of that, Gree. What's going on there? Huh? What's going on there? Why is it not crashing? Okay, it's broken now. Okay, it never crashes. That's not the issue. It's not a crash. It just stops. Huh. Introspective days. Good thing about life decisions, but not a good day to take them. Oh, wait, it came back? Hang on. That was very unsurprising. No, it wasn't. It was very surprising. Ah, there we go. So we got a panic to start with. We are trying to open a connection, but we can't. Tell you what, though, Greek, it's very healthy to do, and one of the things that I have to do these days, I'm saying this out of solidarity, right? Because I understand that there is some pain points in life, right? So I have to do this thing, right? Without getting into any details, any boring details. I have to do this thing all the time, every day, right? At least a few times a week. And it's this: find yourself in an uncomfortable situation, see how uncomfortable it is and how long you can stay in it, right? So right now that can be, right now my what now? Let's not get into the stupid nervous system thing, but the long and short of it is, doing something like that is a pain point, but it makes things better in the long run. I met someone who goes through a similar thing to me physically. She's going through similar things, right? But we have very different reasons for being where we are. She has quite legit reasons. I just have like basic bitch burnout, right? She has something more severe. But I was talking with her and we were both laughing because she told me about one of the things she was doing that she didn't like doing, that she had to put up with. And I said, the worst part of this is that you do the hard thing and then you get no reward afterwards, right? If you're brave or you do something that you didn't normally dare to do, or if you overcame something, you usually get this like reward. Your brain can just go like, oh, well done. But with this stuff, it's like, no, now you're going to feel extra shit for a while. But it's good in the long run. It's good in the long run. Okay. So yeah. Okay. So we ended up here, and this is where it panicked because it timed out. We're trying to open a unidirectional socket from a connection. So where is world updates coming from? Yeah, so we're just doing that, and it's quite all right that this thing fails. So here we're just gonna log the frog, okay? And then here we have to return okay. So we're effectively ending their connection here. This is sort of clean up through errors, right? Most significant bit? I don't know, Dayloop. Okay, here's another one, right? We are accepting a unidirectional stream, but it's the same thing, right? So one is open, one is accept. So let's match on this thing again. Okay, let's run through this again. it was kind of, I understand why it started up again, but there's something afoot here. I think what we need to do is we need to deal with disconnects, basically. Okay, this should happen now. Okay, there it got stuck now. Might take like 30 seconds, right? There you go. Whoops. Yeah, so we just get timeouts there. But why is that blocking the rest? That's not okay. That's the big issue, right? Basic bitch burnout is an interesting concept, I'd say. Throwing yourself into hard things, not having the impact progress effect that I was expecting. Huh. Yeah, that is a difficult one. Oh, don't come in here, Bumblebee. Get out of here. What even are you? Oh. Okay, so we're slowly getting some trajectory for the day, right? Right now, this is indicating that we are not running the world because we're blocking on a connection, right? That's sort of silly. So let's go and find out where that is happening, right? We have something boring that we have to do, right? Let's see where we're printing out the frame. Let's start with that. Here we are. So we've done all of this. Nothing here. There's nothing. We're not awaiting anything in here. Wait, I think maybe maybe this. Maybe this. No, not at all, Eagle Beagle, right? Not even a little bit, right? I think you are more than okay with that. So what would I say that you get from you know, Eagle Beagle, you know what I think the hardest thing for you is gonna be with learning Rust? It's probably gonna be the fact that you wanna take the wheel when Rust is driving. I think that's gonna be the hardest thing to overcome is the but I know what I'm doing, Rust. Let me wrangle the raw pointer, right? Because Rust has a lot more stricter invariants they have to uphold with raw pointers than C++. So yeah, I would say don't get the book. You'll blast through the book if you've done. You already had that experience. I quit Rust twice. Oh. I quit Rust twice because I thought it was being a silly. Which gadget? But if you stick with it, it's worth it, right? What happens when we get to 2.0? Do all things break? When we get what? To Rust 2.0? Is that what you're saying, Enrico? Are you trying to make a joke? Is that what's happening? We very good. And returning to Rust, oh, lazy modder, that's cool, man. That makes you instantly 30% more attractive to the opposite sex. Whether you care or not is a different story. And there is zero evidence to back that claim up, right? Okay. There are times you personally know which part of structure you can mutate. You can explain it to the compilers you need to split things up on. Rust is a roller coaster. First is frustration, then it's comfort, then it gets annoying again. Eventually, it's just the most reasonable option. I think what happens, Rensky, is that we kind of just surrender to it, right? I try to think of things to show people on stream sometimes. Like what do you do when you implement two different traits for a type, and they both have the same function name and function signature, right? And I barely remember the syntax because I never do it, right? I never end up in the situation, right? There are so many situations that I never end up in. I think one of the most interesting things to do with Rust, though, is to think about what is actually happening when the borrow checker says, oh, I can't let you do that, Dave. Go fuck yourself, Dave. All right. This is the less pleasant borrow checker, right? But every time it does that, and you start to, if you follow the logic, what can happen if it allows you to do that? You will generally, like 4 or 5 times or whatever, you will find some foot gun further down the road where you realize that there was no way of solving this without either a mutex or not having a pointer and things like that, right? I think exactly, Enrico, exactly. No, but there's like so one of my favorite things is like the how Rust won't let you borrow a value from a collection and allow you to mutate the collection at the same time, right? I mean, yes, there are things that you can do. There actually now with the newest version of Rust, we can do something really cool that I've implemented in what we're doing here, right? But if we do this, right? Whoops. Let's say that we do this. We'll have a vec of values. So we're gonna do this, right? Right. So the reason I make a box size of this is this can no longer reallocate, right? So I'm gonna show you what it can be annoying for no apparent reason, right? And there is no reason why this shouldn't work, right? I mean, there are many reasons why this shouldn't work, right? Okay, so Rust won't let us do this. So the reason it won't let us do this is because it can't check what 0 and 1 is, right? It is an ident, curly bracket, and a literal, but there's no check to see whether these literals are the same, right? The reason this fails is because you could have had something like this, right? Let's say you have user input here, and then index 1 and 2. Oh, beans. Okay, what a roundabout. But there's nothing here that prevents these two from being the same value, right? It is being reasonable, yeah. Yeah, you kind of become familiar with these things, and you also learn to work around them, right? There is a way to achieve this, right? To have mutable access into this thing, right? And it's a pretty clever way of doing it. You can write it as value 1, value 2. I think something like this, right? Not get mute. The standard library documentation is so good. We're looking for a const generic. Oh, there are so many now. There are so many different ones here. I'm looking for the this one is cool as well. This one allows you to insert a value and instantly get mutable access to the value, right? So in this case, what you might do is you might add something to a collection, but now you want to mute. You say the logic goes a bit like this. Does the value exist in the collection? Yes. Get the value and mutate it. Otherwise, if it doesn't exist, then insert it into the collection, get the value and mutate it, or whatever. You're going to return a mutable reference to the value, whatever it is, right? So this thing allows you to kind of do things like that, right? That was a little bit roundabout and possibly a little bit incorrect the way I expressed that. But either way, let's give the nerds over at YouTube something to gripe about. I'm going to find it now. Extract if used to be called drain filter, and this one I was waiting for this for so long that I no longer needed it by the time it's stabilized. That's nightly. I wish they had a way of not having nightly, right? Where you could just filter out documentation for nightly features, because a lot of us don't use nightly, all right? It's just a sneaky thing. There is well, I'm looking for something with const generics here. It's gonna be fine, all right? Const n. That's nightly. That does not take a... Wait, is it const? Yeah, it has to be const generic for that to work. And it's supposed to return... It's supposed to return a mutable t of size n. Oh, maybe it's guessed. Maybe this is literally what I'm looking at here, right? Yes, this is it, right? So get this joint well, not unchecked though, right? There we go. Get this joint mute. So this one allows you to push it or pass the indices that you want in and get the values out. And how this is different is that it will actually panic. Save, right? Memory save. Get this joint mute. That's the one, right? So get this joint mute. There we go, right? Oh, that gives us a result. Well, let's go uncheck them, right? Was it unchecked? Unchecked. There we go. Oh, that's unsafe, is it? Beautiful. Well, we can just unwrap because we know that it's fine. In that case, right? So anyway, this will give us the different values that we need. And I use this quite a lot in the game library to allow you to create scenes, or sorry, create layers. And then you can get all the layers out as you need them. Main layer, debug layer, UI layer, whatever layer you want, right? So this is really useful to have, right? Yeah, there is definitely going to be things that one can get angry with because it doesn't exist in Rust and you might be used to it from C or C++ or whatever. Right? So there's definitely issues to be had, right? I think maybe this is the issue that we're sending to the output, but the output gets full. There we go. Right, so the output gets full here. Output is probably bounded, right? We probably have how many world TX do we have? Where's world TX? There we go. Yeah, so after 10, it gets stuck here, right? So this is a balancing act then. Oh my god, I'm so sore. Jeepers peepers, man. I went for a walk yesterday and now I'm hurting. You have been. So what the point of that is, Araga, is to make a square, a cube, which is hollowed out, so I can pour wax and add a wick to it and make a candle if I choose to finish this thing. I just wanted to... Don't make me fall back to mom jokes, Rensky, okay? It's too simple. The goal was to make something... yeah, then exactly, no candle thing. But I don't know if I'm going to make a candle out of it or not, right? So we are stuck here. So if we do this, right? Trying to send, and then we say send here. We're going to see 10 of these now, I think. I think that's what's happening, right? So now we break that. So trying to send is still happening there. Although I don't know. No, now it's stuck. It's trying to... or is it? Yeah, it's stuck. This one is not doing anything. It's stuck because there's nothing to... like, we are stuck on the channel, right? Oh, it's so warm today. This hot coffee surely helps. And then it kind of gets dislodged after it times out. So, oh no, it's the wrong project. Multi-pants server. This is the, I guess this is the pain point of doing things asynchronously with a bunch of stuff going for it, right? You have to deal with the problem somewhere, right? And we have a rather obvious way of dealing with the problem here, right? We're basically going to have a timeout occur if you haven't said anything for like a second, right? Then we're going to time you out. So how many outputs can we send in a second, right? Let's answer that question, right? So if we are sending every 50 milliseconds, right? So that's 20 outputs before it times out. So if we were to quadruple our bounded queue from 10... well, that's something else. That's the server thing. Okay, we're going to leave that one alone. We're looking for 10 here. To 40. And so now it can store more things in the queue. Then we're also going to say that any connection that we get is going to time out if nothing has been sent within 1 second, right? That's kind of a brutal timeout. But if you think about this, 20 times per second is the number of inputs that we are sending, right? Every client is sending the input map 20 times per second, right? I have to think about the input. But that means that our server needs to have a timeout of, let's see, where's the main function for the server setup here, right? Server builder with address. Well, we have to have some kind of like with timeout, with keep alive. There we go, right? So with keep alive for a duration of 1 second. So that's the maximum. Is it keep alive as one word? Where's the keep alive thing? With keep alive. Ah. No, not ah. Aha, there we go. All right, so this should no longer be a problem, right? We should no longer be stuck on trying to send because it will just time out the client, right? Whoops. There we go, right? Okay, it's not letting me move though, so something is stuck here. Okay, so we are stuck on something. There it goes, right? Connection timeout. So that timeout did not seem to respect the keep alive thing. It's not keep alive. It's a max something with frame time. No, that is not it. We're looking for a maximum here, but it's not in there. Okay. That's a shortcoming. That keep alive is probably per client, right? Let's see how this is being used. Yeah, this keep alive interval. We're looking for one called max idle time. That's the one, right? Max idle timeout, right? But we're not going to use keep alive interval for that. And that can apparently fail. So let's have a max idle timeout on there. There we go, right? Good old copy and paste. Okay, then. Now we just have to have a with max idle timeout in here as well. Okay, so if we set the server now with max idle timeout, I think keep alive is not doing that is doing something else. I don't know what the default for that is. We'll find out. Okay, so let's try this again, right? So cargo run 1. Whoops. That was very additive. Okay. If we then end this one, we can still control this thing. Let's see if it disappears. No, it's stuck. Ah. Okay. It might be a 2 coffee day. Yeah, there it got unstuck. And there's all the input that had been accumulated. But now we're getting no input anymore, right? Now the input's dead. So, no. Wow, okay. There is something really strange going on. And I don't know what it is, but we are no longer able to do the input has like this insane lag. So there's something else happening. I don't know why he's doing that, but I guess the plot thickens. No, it doesn't. It continues. Okay, let's put the keep alive in there as well and see if that has an impact on this, even though that is not really what we're looking for. All right. Okay, we can still move this guy around, but he's never removed, right? And he should be. Okay, it seems to be working now, other than the fact that he should have disappeared. Okay, so we need the other timeout as well. Okay. Hello, Skylar. How you doing? Yeah, that was quick. That made sense. Hello, Rainby. How you doing? Okay, well then there's one more thing to test before we dive into what is arguably going to be the boring thing. No, don't want you to find the window. Then split that. There we go. Okay, so we can control this. So we're just gonna move this back and forth. Swap windows there. Let's see if he stutters now at all, this guy. Nothing. I think the timeout is making this work. So we have a big enough buffer that it will fill up the queue. It will still have data to put in the queue before the timeout. So this is fine. All right, I gotta figure out why that guy isn't disappearing though. That's a little bit unbecoming of him to not do. So on our client, can we run this again and will it work? Well, yeah, that kind of works. And now, wait, why is there only 4? If we do this, will we have 5 now? Yeah, okay. No, it is correct. Well, it's not correct, but it is persistent. Okay, let's dump the number of players we have on our server as well, right? How do you suppose? Either you're right or you're not, Skylar, right? You can't just suppose left, right, and center like that. What's inside the world? Now we're gonna see how many players we have. 1 player. Still 1 player, even though we dropped. Okay, so we are not removing the player on the server. It's not a client issue. It is 100% a server issue. But the question is, how far do we want to go with this now before we... how far do we want to go with this before we start making it a little bit more... What's the word I'm looking for? Generic, right? So it's the point of this exercise is to figure out how multiplayer gaming works, find the sharp edges, unify things into a library if we can, and then build something with the parts that we can then try out by getting a cheap Dio droplet and running it there, right? Does anyone have a new set of ears? Mine are being difficult. Okay, let's have a look at what it's like when the server accepts a connection, right? So handle connection does what it does here. These unwraps are probably, let's do some error handling here instead, right? Okay, says. Really, what we could do. Wait, there's no. How does this work? This needs to be in a loop. Otherwise, you can't reconnect. All right, so this needs to be in a loop so we can reconnect. I think I just said that, didn't I? All right, to the readatorium. Well, this was useful, right? All right, so after an incoming session, what do we get? We get a session request. I am pretty sure I saw this somewhere. Okay, so this Twitch is doing the usual thing, so I have to go and block some elements now. Oh, goddamn, it's the most annoying thing ever. It isn't. There are many more annoying things in the world. I just like being dramatical for a time in the morning. Dramatic in the morning. Okay, let's go with web transport. Accept multiple connections from the same connection session, right? Or session reconnect. Let's look at the session. There was a distinct lack of session information. How's it going, Armadan? So not that. What about here then? Okay. No session there either. Can we use a search here? Let's try that. Okay, what if we do web transport reconnect? See if that has anything then. It keeps coming here, but I can't find anything useful in here, right? I'm not finding what I'm looking for. Maybe in here. There should definitely be enough information here. All right, let's go and read. Has the following capability defining blah, a session, but Except that this one isn't optional, right? That one's hard-coded, but that's okay. Can we clone a session? We cannot. What about this then? Should we do that here then? That also is a move. But is a session request something that we can clone? It is not. Okay, so we cannot loop this malarkey. But what about reconnect, right? Web transport, reconnect to the same session, right? This should be handled in there somewhere. Stop giving me this link, okay? No, not WebSocket, you ghoul. All right. Okay, maybe these two will give us something then. Okay. All right, in that case, we'll come back to this, but we just say there's no session ID or anything like that, right? we could give the connection a session cookie, all right? Or more importantly, we could give it a what could we give it? We could give it like a key and an ID when it connects. So if you want to reconnect, you have to send the key and the ID, and then you can resume your you can reconnect, right? But that's a server detail, right? That's how. If we do that, that's up to the server to do that, to make that choice. We don't want to make that choice yet, right? So we're not going to do that yet. Okay, so it's these two that can fail. And again, this is a classic async problem, right? Oh, I forgot to fix my audio. Damn it. Boo. Let's have one quick look here. Okay, it was actually not, that was an easy fix. It was not set to mute. It was set to very low volume. So I keep getting like a feedback into my own brain there. My own voice echoing back to me. Yeah, so we spin off two individual tasks, right? We have the world update task and we have the input handling task. They are unaware of each other. So there's not really anything we can do with these ones, right? One of them, we can probably do the world updates, can be the dominant one, right? If this thing fails, it's just gonna end. It's gonna end somewhere completely disconnected from everything else, right? And if the world updates fail, Actually, neither. Here at this point, we should do something like server tx.send async server command disconnect something. I don't know what it is that we're doing, right? We should have something like that. So that means that both of these have failed. So this can be a handle, and we can do a handle await here to make sure that this one shuts down as well, right? So this should only happen if the input is breaking, right? Yeah. I don't know if you heard that, but I just clonked my teeth. So the input handling and the world update handling looks very similar, right? We have for the outgoing data, we have a channel that goes to a stream that writes everything and then closes. So this can be packed into one type, right? This could be packed into like a unidirectional outgoing type. Where, what are we actually getting here, right? We're getting the arc. We could have used the bytes crate for this, but an arc-u8 is fine, right? We are specifically doing multiplayer, so the arc makes sense right now. That is not where the bottleneck is here. What about this one? This one could be incoming, right? So we're gonna take this socket and then map it. No, we accept the socket, we read from it, and then we send it. So it will be new unidirectional stream, incoming unidirectional stream, read from the stream, send the output, right? That's that again. This could be folded into one type, right? Okay, so that makes sense. So the server should have some kind of message that we send to it. That could work actually. I think that should be maybe where we take this now to simplify it. Because we need to handle disconnect. That means that we need to be able to tell the server something. Like, what is it that is happening? Most of the time in this one, where's the server TX? Here we go, right? No. That's the RX. Here we go, right? Oh, biscuits. Where's the... it's the world TX. No. It's the server TX. Do we drop that afterwards? We do. Okay, I am forming a bit of a mental model of how all this now hangs together. I'm worried that I might be missing some detail. So let's think on this for a second. Then we're going to get to some programming, right? So we have our inputs, we have our output. Okay, there's one thing that we are missing, and that is the bidirectional streams. So we have a persistent bidirectional stream that we should use for something, right? I just don't know what yet. Let's just take a moment to appreciate that we're doing all this with Jason as well. There's no like good encoding or whatever, right? It's all just Jason encoding. But JSON is definitely easier to read than like bin code or whatever. Right? There are different encodings that are suitable for game dev, but we're not getting into that now. The advantage of using Serde, it has disadvantages, but one of the advantages of using Serde is that we can just swap the encoder between debug and release build. So if we output JSON in debug, we can output some other format in release build, right? It might not be bin code, it could be something else, right? There are a few different ones, but like I said, we don't have to decide that yet, right? We don't have to decide that yet. Okay, so let's see. Should we do one last thing then, where we create this sort of this chatter, right, between the server and the client? So, oh man, bunny hair everywhere. Let's do it though, right? Let's do it. Do the work. Okay, handle connection. We'll do another one. So this is the handle in the handle input handle handle input handle. H1. Okay, cool. And H2. And we're doing this just to dispose of these. We're doing this to dispose of them, right? So we have handle input. Let's do one for handle chat then, right? It's quite liberating to be able to clone the connection so cheaply and not have to think about it in terms of like, oh, do this, split this, do that, right? Okay, so here we're gonna have a stream that is connection, open, a bidirectional stream, await that, and unwrap that. Open uni, accept uni, open by. We should probably have, do we need an accept by as well? We do on the client side, so yes. So this is a send stream and a receive stream. Then it's a question of where do we open this, right? We can open this on the server or on the client. Well, if we go back to us sending data to, no, reading our input. So we'll do it here, right? So we'll do handle chat. That will be accept, not open. And that's gonna be our send and receive, right? Okay, so this one is gonna be a little bit stranger, right? Because we are spinning up another task from here as well. on swell, right? On slow. I'm cosplaying as Onslow. I just need a hat, man. That's a good look, man. That's a good look right there. I like that the fuzzy dye is on the inside of it as well. Oh, bless. How you doing today? I actually looked for something stupid to wear on my head, but I couldn't find. At first I thought I could wear a headband, like a sweatband, but I don't have any of those. And I don't have a hat that I can use to go full douche, right? Yeah, if I would have had like a sweatband, that would have been pretty good. And maybe one glove as well on my hand. Oh, embrace the 80s, man. That Karate Kid one with the sun. All right. So if we do this, then we have to read on one and write on another, right? So how can we fold this into? So these two are easy, but what about this one? Could this one be a combination of both, maybe, right? A chef hat. Oh man, I don't have one of those either, right? What is like the one that's a little bit tilted on the side, or like a full straight up, right? Like this or this, right? The left one or the right one? What do you think? I mean, look at that one. That one has some kind of band and everything, right? But the you cook is no, you can say shit here. That's not gonna be censored, right? But you also shouldn't cook fecal matter, right? That is unhygienic. Okay. So send stream and receive stream on. Which one do we send where to? Because these streams are supposed to stay open, right? Opere. Are you confusing the British with the French now? Anyway, so this is a stream that we receive from. So it should never finish, right? Or am I thinking about this the wrong way again? Let's have a look at the example. There were some good examples for this, right? Let's see. We have web transport examples, game, video frames, and something else. I don't remember what else it was, right? We're looking. There we go, right? This one will probably have it. Here we go. All right, let's look at the examples of this, right? Because it could be, it is so conceptually foreign to me to have the stream open, written, and closed, right? That to me just sounds so weird, right? It speaks volumes of your past. Anyway, so what happens when we open a bidirectional stream? Are we supposed to read, write, and then close that? Is that the thought, right? So let's have a read. Here's an example of sending and receiving streams of data following best practices in the stream spec. So that one was like, yeah, so this one just goes somewhere into the spec. We should probably look at that, right? So there's a couple of things to do. It's we have to look at this one. For the multiplayer, this has a good description, right? It's fine. Am I a bot? No, I'm too into what I'm doing to like be roped into that, right? Okay, so this one has a good description on how we're going to do interpolation with frames and all that stuff. So this one, I have to look through this one. There's a lot to unpack in here. Then it's worth looking at this one too. But as you can see, this is not a light read either. And then we have this one. So we're going to start here. Okay. Custom headers, probably not something that we have to care about. Here we go, right? Examples of sending and receiving streams of data following best practices, right? So we get a writer, we write some data, and then we send it to a unidirectional stream. Okay, so this one does not open a bidirectional stream. Okay. Okay, use bidirectional stream as a request response pattern. Yeah, I think streams aren't meant to exist, right? They're meant to pop in, be written to, and then disposed of. They must be very light in that case then, right? There's nothing here that says otherwise. So what is the point of the bidirectional streams for web transport? For reliable transport, provides access to receive for reading, incoming, and send for writing. It just seemed to be like a request response cycle then. Okay. I think maybe there's so much information missing, right? From here. For B, that is, right? Okay, let's do this. Let's skim through this. We can't use reader. Briefly then, right? This specification pro. Okay, we're not going to read all of this. I just need to skim through this to see if there's anything missing, right? This is a heavy topic, right? There's a lot going on here. Right, maybe not a heavy topic, but there's a lot to digest. So we're gonna try not to get too stuck into reading, right? This spec provides APIs for creating, composing, and consuming streams of data that map efficiently to low-level I/O primitives. Okay. Large swaths of web platforms are built on streaming data. That is, data is created, processed, and consumed in an incremental fashion without ever reading all of it into memory. The stream standard provides a common set of APIs for creating and interfacing with such streaming data, embodied in readable streams, writable streams, and transform streams. These API has been designed to efficiently map low-level I/O primitives, including specializations for byte streams where appropriate. They allow easy composition of multiple streams into pipe chains or can be used directly via readers and writers. So we don't have the pipe chains or anything like that, right? They are designed to automatically provide back pressure and queuing. This standard provides a base stream primitives which are part of the web platform, can use to expose the streaming data. For example, fetch exposes response bodies as readable stream instances. More generally, the platform is full of streaming abstractions waiting to be expressed as streams, multimedia streams, file streams, interglobal communications, and more benefit from being able to process data incrementally instead of buffering it all into memory and processing it in one go. It's kind of exciting that we have such a basic interface to do things like video streaming, right? If we wanted to. By providing the foundation for these streams to be exposed to developers, the stream standard enables use cases like video effects, piping a readable video stream through a transform stream that applies effects in real time, decompression, image decoding, blah, blah, blah. Okay, a chunk is a single piece of data that's written to or read from a stream. It can be any type. Streams can even contain chunks of different types. A chunk will often not be the most atomic unit of data for a given stream. For example, a byte stream might contain chunks consisting of 16 kilobit uint8 arrays instead of a single bytes, right? Readable streams represent data, a source of data from which you can read. In other words, data comes out of a readable streams. Concretely, a readable stream is an instance of readable stream class. Should we like pop this open very briefly? Okay, there is nothing meaningful there. Okay, here we go. The readable stream class is a concrete instance of the general readable stream concept. It is adaptable to any chunk type and maintains an internal queue to keep track of data supplied by the underlying source, but not yet read by any consumer. Okay, so how are we doing reading, right? We have no like read to end. We just read. So really, this read should possibly be done until there should be a read until there's a read exact, but really we should be doing more reading than what we're doing, right? So we should loop this. And if the connection is well, maybe that's not what this means anymore then. So maybe this is where the connection is closed, and maybe this is not a connection closed. Maybe this is simply there is no more data to read. So let's dig into this thing and see what happens when it reads none. No documentation, okay. Read data contiguously from the stream yields the number of bytes read into buffer, or none if the stream was finished. Okay, there we have it then, right? So that, another misconception nail, right? So this one is not an error. This is just stream done reading, which means we break here. If we get an error, we might have to break the outer. Although that should try to do this and that will break. So we could break the outer one here, or we could just let it go here and fail there. This one should fail if the connection is closed, right? Okay, what's a driver error? Yeah, I think we're good. there is a possible value in doing this, right? But we don't have to add things just yet that are not possibly relevant, right? Okay, so let's continue. Most readable streams wrap a low-level IO source called underlying source. There are two types of source: push source and pull source. Push source push data at you whether or not you are listening for it. They may also provide a mechanism for pausing and resuming the flow of data. An example push source is TCP socket, where data is constantly being pushed from the OS level at a rate that can be controlled by changing TCP window size. Pull requires you to request data from them. The data may be available synchronously. If it's held by the Jesus fuck. Hang on. I think someone accidentally turned on a stereo. One of the neighbors turned on a stereo, and someone had fiddled with the volume dial, so that was very loud. Hello, Keller. Yeah, we're doing networking now. Pull source requires to request data from them. Data may be available synchronously. We're doing network gaming, right? If it's held by the operating system's in-memory buffer or synchronously, if it has to be read from the disk. An example, pull source is a file handle. Okay, so in our case, it's a quick stream. So can we see what type of connection we have? So I think maybe there was an example to show that. Or not. So it's a little bit uncertain how datagrams and Quick fit together, because Quick is built on top of UDP, right? Let's verify that. Yeah. So if Quick is built on top of UDP, what's a datagram in that case? And do streams have guaranteed that? Well, no. The thing is, it's not that simple. Streams don't have guaranteed delivery. If you change the priority and send again, then the earlier stream might be discarded. So there is a possibility of that. Okay. I thought I saw something in here that printed the type of connection. But I might have been mistaken. Okay, it might be on the session, maybe. New session. There's an authority and a path. What does the session request path look like? All right. Session request. Where are you? Is this a session request? That's a session request. So let's see what a session path will output. And what's that then? All right, why don't we just dump this? And then we slap a panic on there so we don't have to see anything. All right, let's run the client. Whoops. Ah. Okay, it's literally a path. Okay, there was nothing more exciting than that. Okay, that was a little bit anticlimactic, right? I was expecting something more interesting. Okay, maybe the driver is the one we're interested in. I don't think we're gonna end up. No, it is UDP all the way. Oh, hang on. Really? Okay. Yeah, okay. This, whoops. This is quite a journey. Oh, Nelly. Okay. There's a lot going on here. Whew, okay. Way too much to unpack in here. Way too much to unpack. Okay, but we don't have to care about that. We just have to care about what is actually relevant to us. What? Okay. Interesting. Okay, so it's gonna be a UDP connection under the hood. There's no TCP in there for us, so that's fine. That's okay. Again, there's nothing here that kind of speaks to how these streams should be used, but I think we have fixed a bug that was there before. Let's run the server now, and let's just look at the client, right? Please, thank you. Okay. So it's holding up. It's doing what we expect it to do. And there the connection went. And that's the connection that's okay, right? So we are keeping the Joy-Con connection. Okay. In that case, whoopsie. I think we're good. All right. So we fixed one thing by reading to the end of the connection that was missing. Consumers lost interest in the stream. That hurts, man. Okay, so there's no, it doesn't really speak to the use case of the streams, right? So I think we should really only care about bidirectional streams if we intend to use a request response thing, right? We don't have transforms. We don't have pipes. Don't deal with that. Don't deal with that. Okay, maybe here then, right? I don't need to leave that running. We urge you to avoid following our example and write your own web specifications. Okay, maybe there's something here though, right? Simplest way to consume a readable stream is simply to pipe it to a writable stream. This ensures that back pressure is respected and any errors writing or reading are propagated through the chain. If you want to be alerted of each new chunk from a readable stream, you can pipe it into a writable stream. You can pipe it into a new writable stream that you custom create for that purpose. Why is Marvin not here? Why is Marvin not in the stream? Okay. But it's so vague. It's so very vague how this is supposed to be used. Using a readable stream's default reader. If the stream is a readable byte stream, you can also acquire bring your own bytes. Bring your own buffer. Man, I'm so fed up with acronyms and initialisms in programming. All right. Especially when they're invented for like really small spaces where, I mean, okay, bring your own buffer might be more common, right? But things, I just absolutely go mental when I see the public Rust conversations using like weird internal acronyms. Like, no, it's guff. Being vague is an issue I have with most networking libraries. It's nice to see I'm not the only, no, not even a little bit, right? That is so frustrating when you have to, like, what's the point of this? If you would have used this acronym in several places, maybe, but they don't, right? Anyway, I gotta find something to gripe about, right? As a tech writer for a long time, and whenever I would interview SMEs that spoke in Japanese, I nearly lost my mind. Game Lago, I want you to take a moment to reflect on the irony here, right? But how do you interview small to medium business enterprises? Anyway, for this example, this code reads the first kilobit from the stream, the first kilobyte from the stream into a single memory buffer, okay? But there's nothing here that tells us what the like, this is how you should use it, right? KB byte. I never really went with to me, a kilobyte is 1024 bytes and a megabyte is 1024 kilobytes, right? That's just how I see it, right? It might be incorrect, but that is just how I grew up, and that is how I always think about these things, right? That obviously does matter in some instances, right? But generally, conversations about storage and the likes, airy-fairy conversations. Now, that's the question, though, Rensk. That's the real question. Okay, so we kind of look through this and it hasn't said anything, right? So we just have to make the assumption that that's how it's supposed to work, right? But it is one stream per frame here. So I think the mental model is solidifying a little bit here. Send groups is not for us. Neither is this. Unreliable datagrams with aging. For data like player position, all the updates are useless. Developers can now set an expiration on datagrams so the browser drops them rather than sending stale data. But how are datagrams different with web transport than UDP, right? I think that's the last thing here, right? Oops. No. No, fuck right off, Firefox. Don't even, okay? All right, now I missed what I was doing. Stupid asshole. Me, not Firefox. Datagrams, read-only property of the transfer interface, returning datagram duplex stream. Unreliable data transmission. Unreliable means that transmission of data is not guaranteed, nor is arrival in a specific order. This is fine in some situations and provides very fast delivery. For example, you might want to transmit regular game state updates where each message supersedes the last one that arrives. An order is not important. Okay, so does it make sense to do that then, right? But then we're implementing stuff on top of that because we have to keep... So a common way of dealing with that, I say, is if I've done this a lot, right? A common way of doing this is to send a packet with some information and you keep sending that packet until the client has acknowledged that it's received the packet. And the client keeps sending acknowledgement of the packets it has received because the server might not receive it. It's the two generals problem, right? You are sending information and you are replying. Oh, what is that? Oh, it's a Dave. Okay, but he's very small. He's just very active. All right. So you're sending data to the server, or the server sending data to a client, and the client keeps saying, what data have I received? And that just keeps going on and on and on, right? So you're always sending like maybe the last 5 packets on the server. So you build up a queue with maximum of 5, and you keep sending that. Don't come this way. No. Go. It keeps sending the last 5 messages in the queue, and the client keeps replying with, these are the packets that I've received. And if the client has received the stuff in the queue, it can be removed from the queue as well, right? So it's a little bit of a like just back and forth thing here, but I think we should be okay with what we're doing so far, right? We kind of have a method of not sending stale data, right? I think so. I think the way we set this up kind of works, right? Okay, so what should we do? We've answered most questions then. So datagrams are just like UDP datagrams, unreliable and silly. All right, that's a characteristic of these things, right? Okay, all right. The last thing to do is look through this, but I think I'm going to die if I have to read through this now. So we should maybe put a coffee on. Maybe. Okay. Oh. Okay. Let's skim through some of this, then go on and make some... Or should we put the kettle on, maybe? Right? Maybe we'll put the kettle on and then some coffee. And while that's happening, we'll read through this stuff. Oh, it's dreadfully boring to read through this. I'm sorry. You have to sit through this. But okay. Tea, coffee. I'll be right back. Okay. Right, so tea will be ready in 3.5 minutes. So let's read through this thing in the meantime then. And let's make it into old man style reading. Multiplayer games based on the source use a client-server networking architecture. Usually a server is a dedicated host that runs the game. Alright. Okay. Okay. The client and server communicate with each other by sending small data packets at a high frequency, usually 20 to 30 packets per second. So that's kind of what we're doing, right? We're sending 20 inputs per second. A client receives the current world state from the server and generates video and audio output based on these updates. The client also samples data from input devices, keyboard, mouse, microphone, etc., and sends these input samples back to the server for further processing. Do we need to sample the microphone as well now? Clients only communicate with the game server and not between each other, like a peer in a peer-to-peer application. Right? In contrast with a single-player game, a multiplayer game has to deal with a variety of new problems caused by packet-based communication. All right. Network bandwidth is limited, so the server can't send a new update packet to all clients for every single world change. Instead, the server takes snapshot of the current world state at a constant rate and broadcasts these snapshots to the clients. Network packets take a certain amount of time to travel between the client and the server, half the ping time. This means that the client time is always a little bit behind the server time. Furthermore, client input packets are also delayed on their way back, so the server is processing temporarily delayed user commands. In addition, each client has a different network delay which varies over time due to other background traffic and the client's frame rate. These time differences between server and client causes logical problems, becoming worse with increasing network latencies. In fast-paced action games, even a delay of a few milliseconds can cause a laggy gameplay feeling and make it hard to hit other players or interact with moving objects. Besides bandwidth limitations and network latencies, information can get lost due to network packet loss. So this is kind of what we're doing, but we are sending world delta, but that's actually the entire world state, which is just the player positions that we're sending, right? To cope with the issue introduced by network communication, the source engine server employs techniques such as data compression and lag compensation, which are invisible to the client. The client then performs prediction and interpolation to further improve the experience. And this is kind of what we're interested in here, right? The other stuff, not so much, right? If you follow player, well, don't care about that. The server simulates the game in discrete time steps called ticks. By default, the time step is 50 milliseconds, so 66.666 ticks per second are simulated, but mods can specify their own tick rate. During each tick, the server processes incoming user commands, runs a physical simulation step, checks the game rules, and updates all object states. So we are actually simulating the world 20 times per second, right? So our frame rate is something like 50 or whatever. But we're going to change that. We are sending data as part of our world, but we need to make a change where we run the world, but we only send the data at a certain time. This will allow us to simulate physics or do collision detection without too much tunneling happening. Okay, tea's ready. I'll be right back. That's a big cup of tea. Hello, Nail Pointer. How you doing? Why is coriander always growing so flimsy, right? Mine doesn't look like this. They're all like thin and spindly and shit. I can relate. Don't look anything like this. All right, Greg. All right, we'll come back to that. Okay, so we need to increment our server refresh rate, but only send the world state. So we can do more, we have more granularity with our collision, but we don't saturate any connections, right? The one from yesterday. No, we're building on top of that, although that's not really a game yet. That's just kind of like a drunk person's business idea so far. Okay, update. After simulating a tick, server decides if a client needs the world update. Okay, after simulating a tick, the server decides if any client needs a world update and takes a snapshot of its current world state. If necessary, a higher tick rate increases simulation precision, but also requires more CPU power and available bandwidth on both server and client. Really? How do you figure that? Because you're not sending more data, right? Anyway. The tick rate command line parameter. Okay, we don't care about that. Client you to have only a limited amount of available bandwidth. There's definitely tearing that's happening there. Okay, let's do xrender output display port 0. Okay. Okay, it's faster to wait for this thing then, right? Set. Tear free on. I can't tell if it works or not. Oh, wow. Okay. No, that is definitely a difference. Okay. Yeah. Okay. Use command to make a snapshot of the current keyboard and mouse state. But instead of sending a new packet to the server for each user command, the client sends command packets at a certain rate. Okay, so this is actually getting to what I'm interested in. The client creates user commands from sampling input devices with the same tick rate that the server is running with. A user command is basically a snapshot of the current keyboard and mouse state. But instead of sending a new packet to the server for each user command, the client sends command packets at a certain rate of packets per second. This means 2 or more user commands are transmitted within the same packet. Clients can increase the command rate with some argument. This will increase responsiveness, but requires more outgoing bandwidth too. So that means that if we go left and right, that would just cancel itself out, maybe. If we, well, I mean, that would make sense if we do that. Like if you send, actually, there's something off with our output as well here. Yeah, look at that. This is definitely wrong, right? So A should be going up. And no, it shouldn't. That is going left. And D is going right. W is going up. And S is going down. But this is additive, right? So we should do... We should do this. Really. And then this is y. And that becomes negative y. That is probably the correct thing to do. Hello, Gabriel. How you going? Hot tea on an insanely hot day, right? Okay, so running this with the keyboard input now, or no, there's no server. Okay, let's run it with the keyboard input. Right, so it kind of gets stuck when it shouldn't. So we're setting the direction, or we're updating the direction of self input. Here we're resetting the entire direction. So we should do self.input direction is a zeroed out vector. Running the wrong thing again. Okay, now it kind of, now you have to hold it down. Okay, let's change that for is pressed. Whoops. All right, let's see how this feels then. Yeah, okay, that's better. So now we can move this around. We still don't have any means of, well, we have means, we just don't care about the player, right? It's going good, mate. It's going good. We're having some read-a-maroo here, right? Through the source engine's code. How are you doing today? With each packet sent between the client server, those numbers are attached to keep track of the data. We don't have to do this because we have a different way of sending data. We do have to have means where the server can request, the server can send a full snapshot of the world. So when the client connects for the first time, they should get a full snapshot of the world. And after that, they should get Delta updates, right? And arguably, the clients shouldn't receive the same updates, right? But for now, we're always sending the full world state because we don't have to bake that in yet, right? Right, the time between the client sending a user command and the server responded to it and the client receiving the server response is called latency of ping or round trip time. Low latency is advantage when playing multiplayer games. Prediction and lag compensation to try to minimize the advantage and allow fair game for players with slow connections. So this is what we're reading this article for, right? Because this article will explain how we can interpolate between the states and how we can, if you have like a high ping, you can still do things that are time sensitive, right? There's means for dealing with this stuff, right? So that's what we're looking for here, right? We recommend keeping default settings. Okay, so server these games to support altering tick rate. Don't care about that. We should probably look into Steam networking as well at some point, but we'll wait with that. Okay, here we go. To do. Entity interpolation. By default, the client receives about 20 snapshots per second. If the object enters in the world were only rendered at the position received by the server, moving objects in animation would look choppy and jittery. Drop packets would also cause noticeable glitches. The trick is to solve the problem is to go back in time for rendering. So this is why we're going to have a frame history now. So what we did in the first game is we kept a previous frame and a current frame, and then we used the alpha value, thank you, not the delta value. We used the alpha value from our physics simulation to interpolate between the past frame and the current frame. This is going to have a bigger history to interpolate within, right? So positions in the measure can be continuously interpolated between two recently received snapshots. Okay, it says 2 here. I was sure this was keeping like a buffer of like the last 4 frames or something, and then we interpolated between the last 2 frames, or I don't remember how it went. But okay. 20 snapshots per second. A new update arrives about every 50 milliseconds. If the client renders time is shifted back 50 milliseconds, entities can always be interpolated between the last received snapshot and the snapshot before that, assuming, though, that there is no bigger lag, right? So if you have a ping of 25 or less, you are, sorry, of 100 or less, that you're fine, right? Source defaults to interpolation period of 100 milliseconds. Okay, so not 50 then. This way, even if one snapshot is lost, there's always 2 valid snapshots to interpolate between. Take a look at the following figure of showing the arrival times of incoming world snapshots. So snapshot interval 0.05 seconds, render time. So we're delaying this until we have a new snapshot, right? So, but let's see how this actually works then. The last snapshot received on the client was at 3:4. Okay, so these are the ticks, right? Or 10:30. The client time continues to increase based on the snapshot and the client frame rate. If a new video frame is rendered, the rendering time is the current client time of 10:32 minus the view interpolation delay of 0.1 second. This would be our 10:22. So the current time is here, and we render what state we had here. So if we don't read any further and we just start guessing at this point, which is my favorite thing to do, we are timestamping our world updates, and when we get a new world update, we timestamp that. Then we're gonna go back in time to an earlier frame and render that. So we end up with something like no. Okay. That was interesting. All right, let's just no, we can't do that. That we can do, right? So let's just distribute these evenly by doing, where's the, that's lining them up, but what about distribution? What does this do? Grouping. Okay, distribute, there we go, right? So if this is where our current time is, or here, then our render time is equal to current time minus offset with 3 Fs. We might have to make that a little bit longer for, right? So we might end up rendering this frame, and we just received this frame. So every frame is stamped with the current time. So this frame will have current time, right? Okay. Apparently, I decided to close the window because Control W closes windows. Fuck, came up with that. Okay. That is one setting I wish you could disable in Firefox without having to go and do something stupid, okay? There is no disable this keyboard shortcut in Firefox, right? It's just, you just live with it, right? But hopefully that makes sense. So we keep a history of world states, and we render based on the current time minus some offset, right? So we can always find the next frame. Okay, so let's go, and since we're making shit up, why don't we just do that, right? Why don't we implement this before we even do anything else, right? Where is our update function? So here we're gonna get world stage, but we can't really do that, right? So we have to say self dot frames dot push the world and now. So let's add that to our game. We add something called frames. That will be a vector of world delta and an instant. We're going to get the world delta, but really we're just going to panic. And then we're going to do something like let world equals self dot frames dot something. And then we run this based on that. Okay, let's make a struct here called frame history instead. That keeps all this for us. We could have put it on the game state as well, but let's not. Okay, so let's implement frame history. World and now. Cool, and then we don't need the now part. We just have that. And then here we'll have a next function that will return a world delta based on what the current time is, right? But Vivaldi isn't based on Firefox, is it? That's a Chromium-based one, isn't it? I keep forgetting. I don't remember. I guess what we could do is, rather than doing that, why don't we just base this on the frame instead? That's even simpler, right? So we do U64 because we increment the frame for every tick. So we can just say how many frames behind are we, right? That makes a lot more sense than doing it that way, right? So frame is a U64. 4, thank you. Okay, and then that's out of frame. I thought there is no frame. Oh, state frame. Oh, really? Okay. And this definitely could live inside the world state, couldn't it? Was it next, maybe? Okay. Really? Damn. Okay. Why would this... Why is this? There's clearly a bug with Rust Analyzer now. Which is okay, but a little bit frustrating. There we go, right? Okay, so how do we get the next frame? We need to know what the current frame is, right? So current frame. And we want to get the expected frame to be the current frame minus some offset. And we'll do self dot wait, that's in the wrong place. So the offset will be some arbitrary number of frames that we're going to store in there, right? And we are not going to allow push to do anything, or rather we're not going to do anything until push has loaded up the correct number of world delta. So we need to skip 4 frames. I just pick 4 as an example. We need to skip 4 frames before we do anything, right? So we'll do self.frames.length is larger than or is equal to self.offset. Okay, and then here we say, okay, well, since we can receive multiple, that one doesn't actually make sense. So forget you. Instead, we just say, I guess we could return an option here, couldn't we? Okay, we'll come back to this. Hang on, no, we're making things up. We can do this, right? Let some else what else return scene. Whoops. Actually, we don't even have to render. We can just do the wait, right? Is there a wait? No, continue. Next is the one, right? So we're even telling, this is kind of minute and meaningless, but we're telling the render not to do anything even, right? So there's 4 frames and then nothing, right? Or nothing for 4 frames, right? Hello, Talk, how you going? I guess that can be a no. In our case, that doesn't matter. So I guess the frame could be a U size just to make things easier. Oh, come on, man. Oh no, we don't care about that. It's going pretty damn well, Talk. We're about to do multiplayer. We're about to run some multiplayer code now. Okay, so that means that we can. Yeah, so we actually need to get 2 frames then, right? So this is where things are gonna get a little bit special, right? We're actually looking at 2 frames here so we can interpolate between them. Okay, so we have the past and the present, or the preset if you can't write. There we go. And then so this isn't quite right. We also have to take the past iter in here as well to be able to do the interpolation. And also we need to know how to spell players. Ugh. You just don't look too closely at this now, okay? Where did we do this? There's a lot. We're gonna just use the ether zip here because that is too painful to watch, right? Well, another delightful word to write. Okay. There we go. Okay, so the sprite is gonna be that, and the position is going to be. That's a sprite ID. Wait a second, this isn't right. That's a sprite ID. That's nothing. Okay, so that will be a loop between the current position and the past position, and I think this. We'll see what this looks like though, right? Hello, Logstar. No, I don't Logstar. Like the only opinions I have is that as a person who don't write kernel code, I really shouldn't have an opinion on it, right? That's my only opinion, that I shouldn't have one. I think people who have to work with it, they can have opinions, and I don't have to work with it. That's kind of, I shouldn't have an opinion, right? I mean, I could have one, but it can't hold any value, right? That's my line of thinking. Can't find, oh, it's a sprite. But this is just writing that, right? Can't we lerp? Sure we can. Or is it the current position lerping, or is it the past position that is lerping with the current position? Is that how this should be instead? Is there not a lerp there? Is there some new drama that I've missed? Because I remember the old drama and I didn't really care that much then. Is there new drama again? There is a but that's what, okay, so I see what I've gone wrong, right? So it's a position lerp of past position, current position, and the time. That's what we have, right? We're not gonna, well, yeah, we can do the write-out. That's okay. But it's like how the kernel is worked on affects me as a user of the kernel, but at the same time, I am not a maintainer or a kernel developer. So let's say that I had an opinion, right? That I wanted to, and I wanted to make this, like, I really wanted to push my opinion on the people, right? Let's say there's a kernel developer who refused to use Rust, and I'd be like, no, you should use Rust because it's so much better than your unsafe C bullshit, right? Like, not using Rust is irresponsible. You're a bad person, right? The only thing that happens is that I am making another person feel bad worst case scenario, something worse, right? They're like, okay, I don't want to do this. This is like the straw that broke the camel's hump, right? Not his back. It's his hump exploded into a cascade of water, of rusty water. Because people, like, if you have an opinion, if I have an opinion, we're like, oh, right, this thing, we have opinions, right? That's two people having opinions. But that's not what happens to these people. Instead, they get to read thousands upon thousands of people having opinions on what they should do and how they should use it and how they should behave and like all that stuff, right? So as long as I'm not directly affected by it, my opinions is that people like me and other non-kernel developers should probably let the kernel developers get on with what they do, because they already have to deal with Linus, right? Who's gonna send them back to kindergarten if they make a mistake? So you do need tea, Abu. Get some tea, right? I also think like forcing C developers to learn and maintain Rust code is kind of like brutal. But here's another thing, though, right? For someone who doesn't have an opinion, I have a lot of opinions, right? I do care about the future of the project, but I again, no, I don't really have an opinion on what they should do, because that's so weird, right? It's like when asshole parents tell teachers how to teach the kids because, you know, they went to school, so they think that they are qualified to be teachers. Just like we use computers, so we think we're qualified to comment on the Linux kernel. If you've never written a line of kernel code in your entire life, why should you have opinions on it, right? Strong opinions from this unopinionated person, right? Was I done? Did I do the right thing here? I don't know. Okay, so we're gonna get the next frames, right? So this one, we need to find this frame and the one before it, right? So self.frames. Oh, here we're gonna do this as well, right? If self.frames.length is larger than magic, self.frames.pop, and then ignore, right? So we have 4 frames in there, right? I guess that could actually be the offset. So self.offset. So we want to make sure that we don't get more, right? You can force people to have taste. I mean, like you could, to be frank, Linus do have the authority to send people to kindergarten. Yeah, but that's the thing, right? That's exactly it, Rebel. Linus is a developer, although he doesn't write a lot of code these days, but he's been arguably quite heavily involved in the Linux kernel from its inception, right? So he can have opinions on it. He can go, this is what we should do, right? This is the direction we should take it in, right? Because like most things need some form of leadership, right? So let's go in this direction. And people might not like his choice as a leader, but that's kind of orthogonal to thousands of voices making people feel bad, right? That is just not helpful. So people are like, I've read the Rust book. The Linux kernel should be written in Rust. All right, are you gonna do it? No. Okay, then maybe we just let the kernel developers do the thing then, right? No matter what people say, I actually think Linus is quite pragmatic about Rust and AI when you hear him talk. Oh yeah, I agree with you, Logso, right? I think he has some good takes on there, right? I do love his take when he was on Linus Tech Tips, and he says people like that shouldn't run tech companies. And Linus goes, "Do you know who we're talking about?" That was such a power comment, right? That was good. Okay, so anyway, we are popping frames and we're happy doing it, right? Okay, let's find the index that we are going to use. So we do self.frames enumerate let's do this in a kludger way, right? No, we don't. No, then we have to store the last one. Yeah, that was pretty good. I think that whole clip was like the whole thing was pretty boring except for that part, man. Okay, so let's see. What do we want to do? We want to take the current frame. So when we store that, we put that. Okay, so we're looking for our offset. Our offset minus the frame. So now we're looking for a frame that has this value, right? Or closest to this value, right? That's the thing. Maybe it's like Hello World though, Rebel, right? I'd imagine that it was some pretty hairy stuff though, right? But saying that, and this, okay, I'm gonna try not to sound like a douchebag, although I struggle with this ensemble, right? Or like this, right? Doing kernel development back when Linus started was probably a little bit easier than it would be if you started kernel development for desktop architectures today, right? So I'd imagine that it was probably like a bootloader or something. That was the first bit of Hello World for that, right? Can you link the text we were reading the multiplayer stuff from? Yeah, sure I can. It's all good. What are you gonna do with talk? If you're building anything like multiplayer in Rust, let's talk. Right, I'm interested because there's a lot of things mentioned in the article that you probably could ignore as well, right? Although if you're not reading it on stream, it's not too bad. I haven't seen you stream for a while. Talk. What's going on, right? What's the key? Okay, so this is the expected frame. So we want the frames that's this or before this and the one before it, right? So let's find the frame. Oh my god, I'm getting stupid again. Subnautica. All right. I don't know, man, if we approve. I wonder if I should do like a reverse on this one as well. That would mean that we store the frame in the history as well. And map it to an index. I know, Time Lord. It's like it's a bit of a weird one, isn't it? Okay, what are we looking for? We're looking for expected and expected -1. But we also have to get a frame, right? We're supposed to have 4 frames, right? So we have to be able to dig out 2 frames from here. That's it, right? Well, that's a good way of learning though, Scott. So stay the course, mate. You seem to be doing well with it. Keep going, right? There is nothing wrong with what I wrote, is there? No. Oh, the I comes before there. Okay, so there was something wrong with what I wrote. And what are we returning this as? We are returning this as previous first, and then there's no way this isn't gonna panic, right? Wow, this is so gross. Let's not look at that, all right? That's fair enough. Yeah, I think the x86, the Linux kernel was probably written for what? Like x86, so probably something like a 386, 486 was probably the first machine, right? I don't know when when did it start the work? Can you imagine what would have happened if, was it like Battle Labs or whatever that had Unix? If they would have just open sourced it, they could have had a pretty big piece of the cake by now if they would have done that, right? People would have cared more about Battle Labs today if they would have open sourced Unix, right? Okay, let's run the server. Let's see if this one panics now. All right, subtract with overflow. That's a beautiful one, right? 180. Another quick fix. Comment does not compute. 186. Wait, why was that an issue? Okay, let's just leave this guy running. No, because he's going to create a player that doesn't exist then, right? 186. Right. If the frame expected and I is larger than 0. There we go. Wow, what a hack. What a hack. Okay. Well, that's doing nothing now. So I don't think it's working. We're sending input and stuff, but nothing is actually happening. And I'm guessing it's because of the lerping thing, right? So let's say that the sprite position is just the current... Wait, is it the other way around? No, previous and current. Yeah. All right, so let's just do current dot position. But that's not right. No, that is not even remotely correct. Whoops. Okay. Why is that not working? Ow, are we not sending the input anymore? We are. Update input. Did I goof up this thing in any way? No, we are sending that. And this is just sending the input there. What did I do then that is wrong? We should be sending the world state. Are we seeing the whoops at all? Now there's a whoops. We are not. That's wrong. There's our whoops. Wait, that's the wrong whoops. Okay, we only see the frame. I probably shouldn't have closed that, but I can probably easily find that. That is kind of wild, right? Why is that happening? Why are we only getting one of these? That's a lot more frames than we are sending. So that's kind of, well, that's because we're running this at 60 frames per second, right? Oh. Okay. So the frame that we're running is not the same. We need a bigger buffer, right? We probably don't need that big of a buffer, but let's see if this one has any. No, it does not. Damn. Okay. We'll do this, okay? No, that's not gonna matter. I think this is where we are failing, right? We are doing the wrong thing here. So the first 14 frames we are ditching. Then we get our expected frame. And then we're looping through self to get the expected frame. I don't think we're going to get a lot of that. No. None whatsoever. Okay, so that is clearly wrong. Frame 1 expected 8,600. All right, so that was definitely not the right thing to do. Maybe the coffee is pleasantly drinkable now. All right. All right, so we are looking at, maybe we need to look at render times instead. Okay, so I made things up, which is obviously very good when you do things, but it's a good way to explore. The last snapshot time was at 344. So this is the last snapshot that we receive. The client time continues to increase based on this snapshot and the client frame rate. Maybe we need to use time, right? But it's always going to be, no, we have to have a delay. We have to have a delay, right? And I thought we could just use the frames for this, but that's not possible. All right, so the client time continues to increase based on the snapshot. So this is the last one, but this is the render time. So we take the current time minus that, and if we store, oh wait, we are still interpolating with a current time. Is that correct? So are we interpolating between these two? Maybe we are. Okay. If a new video frame is rendered, the render time is the current client time minus the interpolation delay of 0.1. This would be 1022, which is here. In our example, and all entries and their animations are interpolated using the correct fraction between snapshot 340 and 342. So we don't, the interpolation time comment here is confusing. So they're interpolated using the correct fraction between 340 and 342. So that's these two. But is this the render time? Right. So we're looking to get this one, and this render time here is going to be the delta value for which we interpolate with. Okay. This kind of makes sense, right? We are time traveling, but we're traveling back in time. We're always observing the past, but that's kind of a commonality when it comes to multiplayer games, right? You are always observing the past. I think that's a good mindset. That's a good way of thinking about it, right? That whatever you do with history, not with the present, because the present isn't available yet, right? Says we have an interpolation delay of 100 milliseconds. The interpolation would even work if snapshot 342 were missing, because then we can interpolate between here and here, right? Yes. If more than one snapshot in a row is dropped, interpolation can't work perfectly because it runs out of snapshot in the history buffer. In that case, the renderer uses extrapolation and tries a simple linear extrapolation of entities based on the known history so far. The extrapolation is done for 0.25 seconds of packet loss. This one I have to come back to, right? Thank you so much, Logstar. Thank you so much. An additional delay introduced in the client-side logic is already on top of network latency, which is non-negligible. The timescale is so wildly off in the diagram. All right. If more than one snapshot in a row is dropped, we can extrapolate. So I have to go to look at extrapolate, right? Good coffee. But before we start with extrapolation, we need to get the interpolation thing working, right? I guess, well, no. Entity interpolation causes constant view lag of 100 milliseconds by default, even if you're playing on a listen server. Okay. Yeah, thank you so much, Logstar. And interpolation causes a constant view lag of 100 milliseconds by default, even if you're playing on a listen server and client on the same machine. This doesn't mean you have to lead your aiming when shooting at other players, since, and this is the clever thing. Oye, mierda, cálmate. Okay, maybe I can just disconnect my headphones from here. Yeah, so when you're doing something on the server, it takes this delay into consideration, right? Solo un poco gammon. Entity interpolation causes a constant view lag of 100 milliseconds by default. Server and client on the same machine. This doesn't mean you have to lead your aiming with shooting at other players, as the server-side lag compensation knows about client entity interpolation and corrects this error. More recent source games is into blah, 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 which you can easily... So we don't really care about that for now. Okay, so let me go and do something quickly. Okay, so we are supposed to find the nearest frame. The nearest frame to... Okay, good. To the current render time. So what I wrote was completely stupid then, right? Okay, let's look at this thing for a second, right? So we need to find the current render time, and we need to find the nearest frame. So is that going to be 340 or 342? The last snapshot in the client was at 344. The client time continues to increase based on the snapshot and the client frame rate. If the new video frame is rendered, the rendering time is 1032. minus the view interpolation of 0.1 second. That would be 1022, which is here. Between 340 and 342. Okay, so we are going to find the snapshot to the left and right of the current render time. So then even if 342 is missing, that just makes 344 the next one. Although in our case, will that even happen? Maybe, I don't know. Yeah, because we don't have head of line blocking. We can absolutely lose frames that way. Okay, so let's pass in the offset is not a number, it's a duration. And I think we said 100, well, the article says 100 milliseconds, right? That is irrelevant. We have to have the offset there. Whoops. Is that how we do it? Do we push the... But do we push the current time? Yeah, we have to push this with the current time, not with the frame time. So that's now. And 100 frames. We shouldn't need that many. Let's say 10. Okay, so to get the next one, we have to look at the time. Yeah, this is the one we actually want, right? And we are looking for the frame that is to the left of our time. All right? We are looking for this frame and this frame. So if we start backwards for frame in self dot frames dot iter, can we reverse the iterator? Because it's a double-ended iterator, that should be fine. Apparently not. I thought this was a double-ended iterator. Okay, no, it's rev, not reverse. Another thing that I haven't used in forever. Let's get rid of all of this stuff because this was just confusing. Okay, so this is going to contain the delta and the time. No, timestamp. Yeah, this has its own problem. So if the timestamp is less than or equal to time, then we have found the nearest frame. The nearest past frame. Is that right? Okay, so this gives us the nearest time, and if we do this, then we get I. And then the frame is going to be the future frame, or next frame will be self.frames.getI, and we return some delta and next. Right. No, can't run that. Damn it. Need to run the server first. Still nothing. Really, I thought that would have worked. I mean, this has to get there, right? Why does it die? We find one. We are looking for, well, I guess what we actually end up finding is these two. We're always looking at the past because we don't get enough frames, right? Okay, we just chuck 1,000 frames in there. It's insane, but let's just see what happens. Okay. Maybe. Okay. I have no idea how this is working. It certainly isn't interpolating in any smooth way either, right? Not yet, no. I haven't played anything in forever. I was saying this on Discord, I have so many fun projects that needs my attention. I have the concrete stuff, the 3D printer, which kind of mixes in with that. I picked up a new furniture, an old piece of furniture someone was giving away yesterday, which is solid wood. It's pretty beaten up, and now that's a project standing on my workbench. I don't know what I'm gonna do with it. Well, I know what I'm gonna have it for. I'm gonna make it into a table to have all my my flower durs and concrete and stuff like that. So it's not gonna be nice, but at the same time, I kind of want to take it apart and make it nicer. And it's just gonna stand in the hallway where I'm just behind the camera. There's a hallway, and it's gonna stand there. So it means I can clear out the hallway. There's so many fun things to do that I have not had any chance to game anything or even think about gaming, right? A friend of mine had a fun idea. He said that I should take these, because people give furniture away all the time. A lot of it is like IKEA fiberboard bullshit, and I have no interest in trying to do anything with that, right? Because it's just gonna fall apart. But every now and then, people are giving away solid wood furniture, and that stuff is basically just raw materials if you spend a bit of time on it. And he suggested to make videos like upcycling these things, right? Or making cool projects with them. But I don't know how to make cool projects, so it's a little bit difficult, right? Yeah, this one is like an old thing. It has been painted, so I have to strip the paint. And that's a lot of fun, right? But I mean, you can do that. I posted a video this morning. I'm gonna delete that video, by the way. So if you're on Discord, if you look at the Keyboard DIY channel, it's a completely meaningless video. But I posted that this morning. But I have a small outdoor space to sit, so I can just take it outside to do sanding and stuff. So a bit of music, a bit of sunscreen, you're off to the races, right? And these are like really nice things to do. And in the summer, you can be outside working on things. And yeah, if you look at modern furniture, to sort of get an idea for what Rebel is talking about, some of this stuff is a little bit, I mean, maybe this one, right? Some of it is a little bit too too nice. Although this does not look good. I do not like. But that's a personal preference, right? I don't like the look of this bed either, right? But if you go to something like an old cottage, right? If we can get to the inside, then you will probably see a lot of furniture with character, right? You'll see a lot of what's it called, rococo maybe, about these things. Lots of probably half of these images are like AI generated, but the point is still there, right? Although that looks like someone just slapped a knife. So that's what you get if you put new furniture in an old building, right? That thing just looks so out of place, right? You got this like butcher block looking thing here, and then that, right? This definitely has a weird vibe to it, but yeah, you get like this nice piece with character, right? Absolutely right. But the Stera look can be a vibe in itself, right? But that kind of goes for your penthouse loft in Barcelona or whatever, right? Not in my, pre-Mesopotamian era. I don't know what this is, right? Oh yeah, we're doing an Onslow impersonation, intricate. But yeah, it's definitely a thing. But anyway, so yeah, I like that, right? So I have I think the wife is not super impressed though, right? Because I'd be like, oh, look at that, someone's giving away a whole table, right? But I'm on the lookout for certain things now, so this thing's gonna find a place the moment I get around to dealing with it, and I might even work on it today, right? But I don't know whether I'll make some videos out of it or not, though, right? It's in the Keeben DIY channel. It's completely meaningless, right? I made it because Enrico said that I never post any progress pictures of anything I do. And this is just me. So not a time lapse, but a highly sped up video of me in a hazmat suit pouring concrete and making basically something to pour candle wax into. If I say candle, people get confused, but and obviously I goofed up with it as well. So I forgot to put mold release in it. So I make the first mix and then I throw it out. Oh, hang on. Oh, that's funny, mate. That is funny. What was I doing? Nobody knows, but okay. Yeah, so it's completely meaningless, but I have an outdoor space where I can sit and do things and all that, right? So yeah, I don't. If I had any idea, maybe I'd take some pictures of it and then just sketch on top of it what to do with it. I mean, we have so many resources. Anyway, this is not solving my current predicament. And not only is it not solving my current predicament, the interpolation is wrong. So I think we should be interpolate between what? It can't be render time and current time, right? I did at the very end. The way I do it is I just hold a sander against the edge, and that gets rid of the bubbles, right? But this was a failed experiment. I tried to put some acrylic paint in with the concrete to see if it had any way of coloring the concrete, right? Because this is quite boring, right? But it didn't. It had like no impact whatsoever. I added white thinking that it could brighten it, and I added blue, which is ultramarine, and it's a very vibrant blue, as you might be able to see in the video. But yeah, there's nothing, right? There's no sign of the color in the concrete whatsoever, right? We'll see what it looks like in a couple of days. I'm gonna let it sit for 2 days before I do anything. What kind of sand do I use? I don't use any sand. I buy pre-mixed concrete and then I strain out the larger pebbles. But buying cement and adding your own sand, you know what would be cool? Like, have you seen like the white Mexican beach sand, right? Good spelling of beach there, right? The trees, like white sand. That would be interesting, baby. Okay, so I don't know how this is gonna work then, right? This one says the interpolation time is 0.1 second. So is it? Well, the concrete powder, I'm guessing you mean cement, right? That would be cement. So cement and some kind of you mix cement with like sand or substrate or whatever, right? Rocks, and then you get concrete from that. So it's a couple of things that you mix and you get concrete. But I go the other way. Is that I take pre-mixed concrete and then I strain out the stuff. But the finish is smooth, right? If you look at this thing, the finish is if focus actually worked, that would be super amazing. Come on, dick camera. Apparently, there you go, right? The finish on this thing, the camera struggles with this for some reason. It's very smooth, right? But that's from a lot of sanding, right? I go the other way, yeah. Okay, sorry. We were doing game dev, right? New frame is rendered. The render time, the current client time minus the view interpolation delay of 0.1. This would be 1022 in our example. And all entities and their animations are interpolated using the correct fraction between snapshot 340 and 342. Oh, so we're supposed to get the time difference between those two, and that's the... Is that how we do it? Good morning to you, Rex. Okay, maybe that's how we do it then, right? So when we ask for next, we also get the delta time in here. And the delta time is going to be as the world delta. There's a timestamp. And then here we need the past and the future. What are you griping about? Can't find timestamp. Oh, right. Past elapsed. There we go, right? And then we take the future minus the past. That's our delta that we return here. Really? Instant elapsed minus whatever elapsed. Okay, and then where we call next. That's the wrong next. Why are there so many next? Okay, next frame can push off, I think. Do we do any lerp in here? No, we don't. So here we have to lerp with the delta time. And where's the frames, man? There it is. So prep current, and then that's just delta time. Okay, let's try this. That sounds like a lot of work. Boom. Okay. Did I go the wrong way here? We take the future minus the past. That's correct. Why would this fail? Oh, that should be +1. Oh, beans. Oh, it's buttery smooth, right? It doesn't do anything, right? I've seen people make their own camera lenses, right? But it definitely requires quite a bit of effort, right? All right, so I goofed up that one somehow. Let's just print out the delta here. There's no delta to be had. Okay, what's the issue then? We're storing 1,000 frames. Okay. That's kind of insane. All of this is insane. What if we only store 4 frames? And when we want to get the next one, we must skip the first one. Maybe that's all we need to do. Nope. I am very fed up with this now. Okay. Hello. Whoops. You're like an insane person, Rebel. You have this like profound depth and interest to you. And then at the same time, you say things like sniff your armpit, right? I cannot place you, mate. You are an interesting person who says strange things, but that's just the internet. And I say strange things too, right? So I should probably not be throwing the first rock, right? But as an observer, that's a compliment in there, okay? You might have to dig around a little bit to find it, but there's a compliment in there. Okay, so if the past elapsed is less than time, but that doesn't work. I am so confused by this. Because it's a lot of wank, my brother. That's what it is. It's a bunch of tosh. That's what it is. Okay. So these, I don't get this, right? Oh, I am probably... I should probably look at this, right? Let's do this. That should be 0 to 1 most of the time, right? So let's not care about the frames for now. Let's just print out the world updates. I thought we could get rid of the wank, but apparently it was already gone. Okay. Oh, wait, are we getting no updates? Okay. We are seemingly not getting any world updates. That is a bit wild, isn't it? What fresh hell is this? Something else is very wrong now. Okay, we had one update. Oh, you stupid idiot. You stupid idiot. All right. Okay. Well, there's one and there's one, right? Wow. Okay. So there's a lot of frames. Wait, what's our actual frame rate? Now I'm a little bit unsure. I think maybe there's an issue somewhere else. Zero is not the right frame rate here, okay? That is not the right frame rate. Okay. Okay. Then what do we do? Zero FPS action game, yeah. Oh my word, Rust Analyzer. Sort your shit out, okay? Okay, this is really confusing. I don't know why it's showing 0 frames per second. Okay, let's go back till the point where we had something working. So instead of pushing the world state, well, we can push the world state. That's fine. This one will make sure that it doesn't go too far. Oh, time. Guff. Oh, god damn. All right, never mind. We got things to do. All right, let's see. Where is the world state? Here we have the world. I think the world is a copy type. The world delta. It isn't. Let's clone it. Yep. Okay. All right. can't write that, you dumbass. Okay. Okay. So we pushed the world. All right, let's do that then. Okay, let's do this. Oh, guff. Right. Then sprite position. No lerping for you, okay? It's just going to be player dot position. Okay. And we can't run that because nothing's happening. There we go. Now we can... No, we still can't do anything. But we are getting frames this time. Thank you so much, Rimmel. Thank you so much. I appreciate that. Okay, this is more like it. We're getting a new frame every 4 frames, right? That looks very good. It is summertime. It is blistering hot in here. But why is it not moving? Right? We're adding... Oh, hang on to your sockets. Okay, we're going to do this. Use start collections. Vec the queue. This is how we're going to do our frames now. That should give us the newest frame first. So when we do the silly thing, which is here, we are getting the latest frame, okay? So we should be able to move around now, like that. Okay, so we are getting... between 0 and 1 frames. So every 4th frame, we're getting a new frame, right? That means that 8 frames leaves us with 2 frames to interpolate from, right? If we're supposed to wait 100 milliseconds before we even start looking at the frames, how many frames do we have then? Well... No, I don't want to do that math. Why am I asking that? That's a very disturbing GIF, Evrex. I'm having too much fun. I felt smart in Rust, as you should, Rumil. As you should. You're all entitled to feel smart in Rust. I guess the next thing to look at, so if we leave this and then we look at how many frames do we have that dates back 100 milliseconds, right? So if we say all frames that are older than that. all the frames. Not really a frame, but a frame in an instant, right? So the newest frame is first. We're actually looking at the oldest frame, right? So the offset is 0. Well, am I stupid? Can you? Oh, right. You can't get ranges from. You can't get ranges from vector queues, right? I mean, you can, but the way a vector queue looks like under the hood is actually 2 memory locations, right? So we have to unify them first, which is slow, but do we care? I don't think so, not for this. So we can unify these with a function called what? Make contiguous. Spelling, man, my only weakness. No, that's right. Oh, right. Okay, so this is kind of an expensive operation, maybe, because you're moving things from one place to another and doing some other stuff. So ideally, it's not something you should call, but now we just want to test something out, right? So for, well, let's just get the slice here. Let's do this. Make contagious. No, that's a different thing. Okay. Can re-borrow that one too. Whatever, nerd. Okay, so if we do this and time how did I think this was gonna work? We need to subtract the offset from time, right? This is the kind of code that you should be a little bit embarrassed writing, but it's okay. It's stream of consciousness, so don't worry about it, right? So we have to, before we can look at from, we should, I think we're already subtracting that. There we go, right? Okay, so we're looking at 3, 2 there, right? Now, is the question is, are we supposed to interpolate between these two? The one that came after. So we say all frames that are newer than. Okay. Whoops. Okay, so we are looking at 1 new frames and 2, 3 older frames, right? Maybe that gives us something to interpolate with. So we want to find I guess what we could do is just do this. This is really naughty, right? We're gonna have to pass in that here. This should give us 2 frames, right? So why don't we do that then? Wait, this is getting the old one, so it should be +1. Bad name. Also bad, but okay. And we need the time difference between them as well, right? So let's do this. That's always gonna be the same. No, it has to be something like the from in here, because that is never gonna change. So maybe something like this. And that's to prevent a panic from happening. But I didn't prevent it well enough. 248. Ah? That's not right at all. Let's look at that. Wait, what? Okay, it's running, but I don't think it's particularly smooth, all things considered. Why is it not panicking? Maybe I hadn't saved it. Oh my god, I forgot what keys to push. There we go. So this is not particularly smooth. So I'd argue that this is not running at 60 frames per second. As a matter of fact, let's increase the speed on the server just because, right? The server should be able to keep up. So now you can see how jerky this is. I think we run this like 20 frames per second. So we have 4 frames, we have 1 new frame. All right, then I just have to look at this because I'm still missing the point here. How is this the interpolation type? That's always the same value. How is this used? The client continues to increase based on the snapshot and the client frame rate. If the video frame is rendered there, rendering time is the current time minus the view interpolation delay. This would be, as an example, all entities and their animations are interpolated using the correct fraction between snapshot 340 and 342. But what is the correct fraction here? All right. I am genuinely saying this to you guys. This might be unheard of, but if anyone has any suggestions, I'm on board. What is the correct fraction here? The interpolation would even work if 342 was missing. Then it could use snapshots 340 and 344. If more than one snapshot in a row is dropped, then extrapolation. But it doesn't tell me what the interpolation fraction is. Here it says 0.1, but 0.1 what? You can't always take these 2 frames or so we're supposed to have that one and that one. So is the interpolation time or the interpolation fraction the time current time minus 100 milliseconds minus is the current time minus 100 milliseconds minus the frame time of 340? Is it? All right. Correct fraction between snapshot. What is the correct fraction between snapshot 340 and 342? Okay, so I tried the past and the current time and the interpolation time, the past minus interpolation time, right? But that doesn't seem to be the right thing. Let's print out what that delta time is then, right? Wait. I don't think I'm using this. No, I'm not using it. Come on. Okay, all right. Well, it lives up to his name. All right. So we need the world. So we need this. Okay, where does the delta time come from now? There, okay. There is, but I am very allergic to watching YouTube videos when I'm streaming. Oh my god, that is definitely not right. Okay. Whoops. So it is still quite jerky. But now we can at least print out what the delta time is. And it should change. Even more useful then, right? Yeah, so this is changing, but why is the lerpen so glurpen? Wait, this is weird. Where does the... That is right. I think this is correct, but for some reason it doesn't look right. It doesn't seem smooth at all. And I'm guessing this is equally shit. Well, now we have no time delta. And why, I don't know. And now we have time delta. But that's not smooth at all. So something else is missing. I mean, this looks correct, doesn't it? We're lerping between the past and the present frame. Why is this not smooth? Why is this not smooth? We probably should do this in a fixed time step as well, but that's not it, right? You're too late, Suji. We moved on to multiplayer now. You can you have to be delusional about multiplayer instead, okay? Hop to it. That is still pretty jank. Okay, hang on. Let me read your message then, right? Let me give it a fair shake. Collision mapping, that in theory is simple to implement, involves a C buffer of sliced object reference endpoints. I don't know why we need that, but okay. I get the points thing. So what's a sliced object reference? From that, you scan through each slice for the first point inside the object bounds. So our sliced object refs, are they regions then? Are they rectangles? And treat each ref attached to those points, leaves the ray tracing power collision to just the object being moved prior to comparing the buffer points next. Not getting it, Suji, though, right? I'm missing some details, right? People actually program IRL. I don't know, Social, right? Maybe there's still some nerds out there. Now, she already saw this, but this might go to live demo tutorial for this stuff. Okay, let's have a look. A 2D shape would be the result of the slices. How do you get a result of a slice then? I am unsure. Have I seen this? Yes. This is the one where you can actually observe linear interpolation. Yes. Yes, Rensky. I have missed this. Let's have a look. This is it, isn't it? No, this is the live demo. This is the one I need. Thank you, Rensky. Thank you so much. Okay. That is the demo, but I want the precursor to that, the actual information. And I completely forgot about that, right? Pre-render status before starting the collision. Javier script, right? This one is the one that complements. This one just tells you about these details, but this one actually tells you about the implementation. Oh man, thank you, Rensky. I have been missing this one, right? This is the first in a series of articles exploring the techniques and algorithms to make fast-paced multiplayer games possible. If you're familiar with the concept behind multiplayer games, you can save and skip the next article that follows in the introductory discussion. Right. So cheating, run everything on the server. The server is the authority. Dumb client, as in client, just renders the game and provides input. Right. Okay. Yeah, let's go here. Okay. In the first article in the series, we explored client-server model with an authoritative server and dumb clients that just send input to the server and then renders the updated game state when the server sends it. A naive implementation of this scheme leads to a delay between user commands and change in the screen. For example, the player presses the right arrow keys and the character takes half a second before they start moving. This is because the client input must first travel to the server. Server must process the input, calculate the new game state, and the updated game state must reach the client again. Okay, so this is a little bit hard to see in dark mode, so we can open this up, right? That would be the player's position, move right one unit. This is the new position on the server, and then the server has to tell the client about the new state. So we're saying that it takes 50 milliseconds per round trip here, right? In a network environment such as internet, where delays can be 10 or hundreds of milliseconds, a game may feel unresponsive at best, or in worst case, be completely unplayable. In this article, we'll find ways to minimize or even eliminate the problem. To be clear, though, we are probably not going to suffer this that much, because I don't think anyone's going to play whatever we make. But anyway, even though there's some cheating players, most of the time the game server is processing valid requests from non-cheating clients and from cheating clients who aren't cheating at that particular time. This means most of the input received of right. This is not doing this. Okay. This is about you are submitting. There's a different model. You're submitting, I want to move right. But you also play, I am moving right on the client. The server sends back, you have moved right with a particular piece of information that allows you to go back in time and chop that history off and say, this is where you and everyone else is, right? Wow, what a confusing thing to say. Only people who have read that article knows what I'm talking about, I guess, right? So if you go to move right, you render that you move right on the client as well as on the server. If you are cheating and you're saying that you have now moved right to a completely different location, the server will send back corrective state to you. So your player will jump, but you are not able to tell any other clients about your cheating behavior, right? Because the server would just give you the truth at a moment in time, and you have to correct based on that. So if there's a deviation between what your state was at that moment in time and the server state at that moment in time, you have to follow the server state at that moment in time. Wow. Okay. This is... I completely forgot about this, and for some reason, I kept mixing this article up with this thing. Talk, are you still in the chat? If you're not, this is the article that you need, not the other one. I'm guessing Talk is not. Is that Talk? Stupid streamer mode, right? Streamer mode is so annoying. I can't see people's name. No, that wasn't Talk. That was a completely different person. Well, okay, let me go back into streamer mode again. Which is now under appearance. That's where appearance, then streamer mode, then turn it on. Many clicks. So that is the point, right? Store snapshots and tick based on delay and those. Yes, the whole point of this, the complex thing here is to get the client and the server to agree on something like a frame number or whatever, right? So if you were to, if we have like the timeline here for the client and we have the timeline here for the server, so you are saying that you are moving to some position, okay? So you have your ticks here, okay? And the server has ticks, and you have to be able to match up the server's ticks with your ticks, right? So when the server says that, okay, this was the source of truth here, you can go up here, scrap all the stuff that came before this, just throw this in the bin. It is now on fire, right? And this is now the relevant thing that the server has. So if there's a deviation from here, you have to go to this deviation and replay everything. So you create a new timeline from here with new ticks, all right? You are storing your inputs or whatever you're doing, and you keep getting information from the server, and assuming that you're not doing anything bullshit, you will not notice anything happen. You will not notice any corrections happening, right? It's just figuring out, and this article will describe this, how we can match up our points here, right? Into happy, okay? Tactical, right? Try to implement randomized server hosts. By that I mean the main server picks a random client to host a session and changes every extra minute hour session. That offloads the scene management. That's interesting. I mean, like, that sounds like unnecessarily overcomplicated for what we're doing, but it's an interesting concept. So if someone is cheating as a server, they're only allowed to cheat for a small amount of time, right? Now I don't know. Doing that, Suji, would actually make cheating easier, because the moment you become the server, you could just change the world state, right? What if we play with people on the moon and Mars? How do we deal with the delay? Listen, Evrex, the whole premise of this is that you're playing with friends. So we've already lost because we're Rust developers, right? But that's only until you reported. Wait, are you saying that cheating is okay unless you found out? Just seize control of the servers and not let people host their own. But why not just have a dedicated server instead, Suji? Why do that kind of round robin server swapping then, right? My best friends are on Mars for that reason. Nobody there knows I use Rust. Ah, there you go, all right? And as an added bonus, the whole planet is Rust colored, right? Or so the government wants you to believe. All right. Okay. Authority servers and dumb clients. It's expensive to have dedicated servers, so offload is the best choice. It's not the best choice. What? How are you solving that though, right? You are inventing some kind of peer-to-peer server protocol then, right? How is this helping? This is unnecessarily complicating something, right? It was an interesting concept, but no. Take the L on your game's competitive integrity. Yeah. Trying to be extreme, preventing cheating only delivers a worse experience. But this is a solved problem. Ah, you got me today, Suji. Fuck. All right. I fell for it. All right. This leads to seemingly simple solutions. You make everything in your game happen in a central server under your control and make the clients just privileged spectators of the game. In other words, your game client sends input key press commands to the server and the server runs the game. And you send the results back to the client. This is called using authoritative server because the one and only authority regarding everything that happens in the world is the server. Your server can be exploited for vulnerabilities, but that's out of the scope of this series of articles. Using an authoritative server does prevent a wide range of hacks, though. For example, you don't trust the client with the health of the player. A hacked client can modify its local copy of the value until the player has 10,000% of his health, but the server knows it only has 10. The server knows. When the player is attacked, it will die, regardless of what a hacked client may think. You also don't trust the player with his position in the world. If you did, a hacked client could tell the server, I'm at 1010, and a second later, I'm at 2010. Possibly going through walls or moving faster than other players. Instead, the server knows the player is at 1010, and the client tells the server, I want to move 1 square to your right. The server updates its internal state with a new player position at 1110, and the player replies to the server, and then replies to the player, you're at 1110. So this is the important thing. When the server replies to you that you're at 1110, when the server replies to the player, you're at 1110, it also needs to tell the client when the client was at 1110, so the client can consolidate this information and say, yes, I was. If the client was at 1510, it then has to start a new timeline from when the server said you're 1110 and then replay all the inputs, right? That's how this works, right? Most of the time be extreme. The server knows by knowing what it doesn't know. The server knows where the server is. Right. Hello, scene, how you going? Anyway, all right, we are getting places. I think you are answering a non-serious comment, Suji. Which one? Scene. I have too many to flex with here, right? I guess you can only see one. Maybe some of these shows. Alright, I don't know. Can you see any of these? Ah, you can't see anything. Anyway, probably for the best. I'm getting at you. No, you're not getting much of a show, right? And the worst one is this. You only get to see the top of that because I did that when I was 17, and I am a little bit. I'm not embarrassed about it enough that I can do gardening without a top on, and I don't care what the neighbors think, right? But I wouldn't feel pride walking down the beach with that, all right? It feels sad and sorry for this dad bod competition. I am winning, right? Is it a pinup? No, that would actually be advantageous though, right? I'm gonna get a tattoo of Kinger from Amazing Digital Circus. I don't know what that means, Seem. You have to treat me like an elderly person on the internet, right? Yeah, the trick to flying, right? It's a web series. By the way, those of you who are old enough to remember the Guild, apparently they're starting that up again, right? The ships hung in the air in the same way that bricks doesn't. Okay, so this is really, really good. I wish Talk was still here. Because this is the article that I think you should read instead. But if he's not watching the stream, then suck on it, Talk, right? In summary, the game state is managed by the server alone. Clients and their actions send their actions to the server. The server updates the game state periodically and then sends a new game state back to the client. It just renders it on screen. The dumb client scheme works fine for slow turn-based games. For example, strategy games or poker. Why did that not work? Ah! Right. There we go. There we go. Fixed it for them, right? All right. So the dumb client scheme works fine for slow turn-based games, for example, strategy games or Balatro. It would also work in a LAN setting where communications are, for all practical purposes, instantaneous. But this breaks down when used for fast-paced games over the internet. Let's talk physics. Suppose you're in San Francisco. My wife would be so furious with me if I'd be like, hey, she's like, where are you? Are you not having dinner? So I'm in San Francisco right now. So I would be murdered if that happened. Connected to a server in the New York. All right. Or is that like New Yorkshire, maybe? That's approximately. Oh, my God. All right. Nothing can travel faster than light. Pfft, shows what you know, right? But my wife's rage can exceed light speed. Not even bytes on the internet, which at the lower level are pulses of light, electrons in a cable. All right. Whatever, nerd. This may sound quite fast, but it's actually a very optimistic setup. It assumes data travels the speed of light in a straight path, blah, blah, blah. Back to example. Your client says able to serve a press right arrow, so we can say 50 milliseconds later. Let's say the server processes a request, sends back the updated state immediately. Your client gets a new game state. You're now at blah, 50 milliseconds later. Right, so let's see where are we at. From your point of view, what happened is you press the right arrow, but nothing happened for a tenth of a second. Then your character finally moved one square to the right. This perceived lag between your inputs and its consequences may not sound like much, but is noticeable. And of course, a lag of half a second isn't just noticeable, it makes the game unplayable. All right. Now we're getting to the nitty-gritty stuff here. TADC is my newest autistic obsession. If you want something fun to watch, I recommend it. So send me a link, scene. I made the trip right this much, but did you do it faster than light, Gab, right? From San Francisco to New York, starting from Spain. Oh, where in Spain though, Gab? ¿Dónde? ¿Dónde en la España es tú? Madrid. Aquí no hay playa. All right, okay, hang on. Just for Gap. Just for Gap. Really? That was not right. Okay, just for you. ¿Por qué Madrid, no? All right. So anyway, that song is actually a bit political, but it's kind of funny. It's cool if you know it, but there we go. Right. Okay. Let's go back to what were we doing? Right. Maybe we can do this now. It's been a while. Do you know that song, Gav? Do you get to hear it a lot because you're in Madrid? Probably something, right? Another way to tackle cheating is to give everyone the same tools. Everyone gets a hammer, and everyone looks like a nail. There we go. We have the game idea of the century. All right. The player is a hammer, and all the other players are nail. Right. So, but your client, you look like a hammer, and every other player looks like a nail. But on the other player's client, you look like a nail. There you go, right? But only one nail is the real one, okay? You knew it? Nice. I've never been to Madrid, by the way, Cap. I've been to lots of places, but always, well, almost always around the coast, right? There's a small town between, what's it called? I lived in Ribaroja de Turia. I lived I lived in the what else have I lived around there, right? Which is basically Valencia, if you will, right? So Valencia. I also lived like further south. I have friends had friends in Malaga, but they've now moved to Belgium for some reason, right? We lost touch. Buying a house here too. So wow, I live near the beach, but my girl's very attached to family and don't want to. Oh, of course, man. You can't pry the Spanish from the family, man. My ex is from Vitoria-Gasteiz, right? And like she was very short. But her abuela was even shorter than her. So there's like a picture of me standing next to her abuela, and her abuela's just up to the side. Like, I was like a giant in the whole like family set. Her brother wasn't that short, but like everyone else was like, oh man. But the really good thing about Valencia is that it's not infested with European tourists such as myself, right? So you get like Spanish tourists throughout the year, but it's like it feels very good, right? When you're there, you don't there's not like a chiringuito every 5 meters with someone, but agua, cola, cerveza, smoke. You want to buy smoke? All right, that doesn't happen there, all right? Which is very nice. Right? I don't know what American tourist is, Rensky. Everyone seems to be from Canada, right? But, I mean, it's cool though, Gab. Getting your first house and all that, right? It's nice. Okay, so in the first article, we explored a client-server model with authoritative server and dumb clients that just sends inputs to the server and then render the updated game state when the server sets. So this thing will be condensed into a simple concept. We just have to codify this, and we're almost there, right? But it is a large country though, right? So being American, you kind of like in Europe, you can travel between lots of different countries. So you can get in your car and drive for like 2 hours, and all of a sudden you have to change what language you speak, right? If you're in the middle of the US, then it's just gonna be US, or the country's so big, right? It'll take you forever to go somewhere, right? To go somewhere foreign, right? All right, good luck, Suji. All right, a name implementation of this scheme leads to a delay between use commands and changes on the screen. For example, the player presses the right arrow key and the character takes half a second before they move. This is because the input must first travel to the server must process the input and calculate the new game state, and the update game state must reach the client again, right? So let's pop this open in a new tab. Right, blah, blah. It's the same thing as we saw before, right? Okay, it's the same picture. In a networked environment such as the internet, where delays can blah, blah, blah. Okay, we'll find ways to minimize error in the internet, blah, blah. All right, so we're going to get to the cool link shortly. We can see this. Even though there are some cheating players, most of the time the game is processing valid requests from non-cheating clients. This means most of the input received will be valid, and the updated game state expected that if your character is 1010, the right arrow key is pressed, it will end up 1110. We can use this to our advantage if the game world is deterministic enough, that is, given a game state and a set of inputs, the result is completely predictable. We can send the inputs to the server and immediately process them on the client. That is, we predict what the game state will be after the server has processed the inputs. This eliminates the delay between receiving an input and rendering its effect. Furthermore, most of the time this prediction will be accurate, so there will not be any visible mismatch once the server does send the updated game state, right? So we will get game state back from the server. We can now wipe our history up until that point, right? But what that means will become more apparent shortly, right? It's hard to experience foreignness where I am is 1 hour in any direction. It's hard to experience foreignness where I am 1 hour in any direction. I'm in foreign lands. That seems like it's easy to experience foreignness then, right? Let's suppose we have 100 millisecond lag and the animation of a character moving from one square to the next takes 100 milliseconds. Using the naive implementation, the whole action would take 200 milliseconds. Let's pop this open in the window and have a look. Server. 10. So this one stays at 1010 for 100 milliseconds, right? And then we animate. Oh, I see, right? But it's a bit tough to go to Spanish countries, or even like, so Germany is not that bad anymore. But if you went to Germany some like 20 years ago, maybe, or whatever, then you'd be like, hi, sprechen Sie English? And they're like, 9. But now it's like, yes, we do. Very well. All right. But maybe if you go to Madrid, but if you go to like rural Spain, if you don't speak any Spanish, you are lucky if you get a slice of bread thrown at you, because otherwise you won't eat. All right. So we have to like play this instantly and then correct. All right, that's what we're gonna get to, right? Since the world is deterministic, and this is what I don't remember. How do we make the world deterministic, right? How do we make a unit on the server and a unit on the client be the same, right? Oh yeah, Celestial. Well, actually, what you have been observing has been multiplayer, right? This thing here, which is completely shit, I'm controlling with the controller, but this is actually happening on the server. So if we go to cargo run this, You can see, well, I run it with the wrong input. So we are watching the wrong one, right? So you can see that we are moving around this guy on the network, but these guys are separate clients, right? But we are not doing very smooth multiplayer, so we're going to smoothen this out, right? But deterministic is the key word here, right? So how can we make that happen, right? Let's look at the picture. Okay, but this one talks about an animation. I guess this is what we're doing, right? We are interpolating the player to this moment in time, right? Are we guessing where Evrex is from? Is it Perkele land, right? Who was it that told me that Neutau meant broom woman in Finnish, and I actually believed them? Okay. In the example above, I choose the number. I choose the numbers carefully to make everything work fine. However, considering a slightly modified scenario, let's say we have a 250 millisecond lag and the server is moving from a square to next 600 milliseconds. Let's also say the player presses the right key twice in a row trying to move 2 squares, right? Using the technique so far, this is what would happen, right? Kusi Saitsaman. That's something epic in Finnish. Is that the actual phrase, right? I mean, I speak fluent Finnish, by the way, just so you know, right? All right, so move right 1 unit, and then we do our an interpolation here, and then we do that, and then here we're at P11. So by the time we get the response from the server, we will have moved back. So this P1110 needs to match this P1110. So we need to be able to tag these with something meaningful, right? 6, 7. Oh, really? I see. I know the ICSI. ICSI, Kaksi, Golbe, maybe. All right. All right. Are you that has some pretty wild nature there though, Everex. Just joined in time, you see. Yeah, we're talking about I was just mentioning that someone mentioned that someone told me that Noita meant broom woman in Finnish, and I believed them, right? All right, hang on to your sockets. Oh shit. Oh no, we're good. Whew, okay. Yeah, but you got like big mountains and shit, right? Okay, so let's find out. This is what it comes down to. And we're gonna get the answer. How do we tell the server and the client that P1110 here and P1110 here are the same things, right? Just after Perkele land, we run into an interesting problem at T250. When the game state arrives, the predicted state at the client is X12, but the server says the game state is X11 because the server is authoritative. The client must move the character back to X11, but then a new server state arrives at 350, says that it's X12, so the character jumps again forward this time. From the point of view of the player, they pressed the right arrow key twice. The character moved 2 squares to the right, stood there for 50 milliseconds, jumped 1 square to the left, stood there for 100 milliseconds, then jumped 1 square to the right. This, of course, is unacceptable. Perkele land. perkele, right? I know like Finnish words for horse. 1, 2, 3. The name of the store where you buy alcohol, I think it's called like Alko or Alke. Did I say horse? I think I said that. For some reason, I know horse. Obviously, perkele and some more rude words I shouldn't say. But yeah. Those are all English. Damn, you got me, Everex. The key to fix this problem is to realize that the client sees the game world in present time, but because of lag, the updates it gets from the server are actually the state of the game in the past. By the time the server sends the update game state, it hadn't processed all the commands sent by the client. You know the name of that song you've been quoting back to me last 2 times now? Do I? Oh yeah. Oh damn it. What's that now? It's like I am nothing in Finnish, right? Something mitään, right? What is that? Damn it. I have the song here, all right? En ole mitään. There you go. En ole mitään. What a song, right? All right. By the time the server sent updates, okay, by the time the server sent the updated game state, it hadn't processed all the commands sent by the client. This isn't terribly difficult to work around, though. First, the client adds a sequence of number to each request. In our example, the first key press is number 1, second is number 2. When the server replies, it includes a sequence number, or the last input is processed. This seems like an easy solution, right? So we are tagging every input and we're storing that input on our own in our own history, right? CG, huh? Okay, so let's open this one up in a new one. Okay, so number 1, number 2. So this one includes number 1. So got P up to number 1, accept it and reapply input. Sentence 1 and 2. Yes, that's the thing. So we have to have a history that we play back from, but we only have to play it back if it deviates though, right? So I think we only need to do something if we get an input that has a different value, right? So when we send input, we need to include, where's the input? Update. What do we do? Here we go, right? Update input. So the shared input also needs to have something like a frame number, right? That should probably be a U64 for various reasons, right? But before we actually do this, we are going to have a look at the rest of the article, right? So if this is all we need, then we can say store a history of everything that you do. When the server replies to you, you scrap the history that precedes that. So you can truncate your history, and if the server response deviates, then you have to create a new timeline, a new history, where you start from the frame that the server replies from, and then you play back everything up until now. So on the client, we store frame number. Let's write this down, right? Let's I'm goofing around too much, right? So on the client, we need to store a history of frame, timestamp, and action, all right? This way, we can take the current timestamp and interpolate everything up until where you are, right? So to play back history, what we do is we take the... Actually, we don't need that. We don't need interpolation. We just forget the timestamp, right? So history playback will output a new game state that is written over the current state. So this becomes the new timeline, right? Maybe it was my location, Everex. Although, of course, I would never live somewhere that Los Frescos would make music about, right? Okay. Now, at T2, the server says, based on what I've seen up to 1, your position was 11. Because the server is authoritative, it says the character position at X11. Now, assume the client keeps a copy of the request it sends to the server. Based on the new game state, it knows that the server has already processed request 1, so it can discard that copy. But it also knows that the server still has to send back the results of processing request number 2. So applying client-side prediction again, the client can calculate the present state of the game based on the last authoritative state sent by the server plus the inputs the server hasn't processed yet, right? But again, this calculation only needs to be done if there is a deviation in the state, right? So it's not necessary to do this if the frames match up, right? So at T250, the client gets X11, last process request was 1. It discards its copies of sent input up to number 1, but it retains a copy of number 2, which hasn't been acknowledged by the server. It updates its internal game state with what the server sent, and then applies all the inputs still not seen by the server. In this case, 2 move right, and the end result is X equals 12, which is correct. Maybe this will cover that, but it seems unnecessary to do this, right? It seems unnecessary to replay this, right? Continuing with your example, at T350, new games that arise on the server. This time it says that X is 12, last process is number 2. At this point, the client discards all input up to number 2 and updates the state with X is equals 12. There is no unprocessed input to replay, so processing ends there with the correct result. This example discussed above implies movement, but the same principle can be applied for almost anything else. For example, in a turn-based combat game, when the player attacks another character, they can show blood and a number representing the damage done, but you shouldn't actually update the health of the character until the server says so. Because the complexities of game state, this isn't always easy reversible. You might want to avoid killing a character until the server says so. Even if they have 000 in the client's game state, what if the character used the first aid kit just before receiving your deadly attack, but the server hasn't told you that? Even if the world is completely deterministic and no client cheats at all, it is still possible that the state predicted by the client and the state sent by the server don't match after reconciliation. The scenario is impossible as described above with a single player, but easy to run into when several players are connected to the server at once. This will be the topic of the next article. Right. So we're only talking about our own input, not what we get from other players, right? Which I guess is what we're going to talk about here with entity interpolation. And this might be where those cool demos are, right? Because we are getting where another player was at some moment in time, right? In the past with the updates. So we do have to replay everything. Okay, right? So here's your game state is written over the current state. So this should always be the case then, right? This should always be the case because this state contains other players' position, etc., right? We are at day loop, but not great yet. Does the client currently keep track of the server's clock? No, I haven't gotten to that yet. We're getting there, right? When using authoritative server, you need to give the players the illusion of responsiveness while you wait for the server to actually process your input. To do this, the client simulates the results of the input. When the updated server state arrives, the predicted client state is recomputed from the updated state and the inputs of the client sent, but the server hasn't acknowledged yet, right? Okay. The net result of these two articles is a set of concept techniques that allows a player to control an in-game character in a way that feels exactly like a single-player game, even when connected to an authoritative server through an internet connection with transmission delays. But that is only one. That is only the player. We are going to add other players to the mix, and we have to do interpolation in that case, right? So if we're looking at where you are along the timeline, right? So this is where you are. This is you. And you are somewhat happy today because, you know, it's nice outside. But then we have someone else, or not you. And you are here at this moment in time. However, when you were here, you sent that to the server. So you have moved here. This is local. All right. Oh, sorry. That person has moved there longer. But you find out that not you is here at this moment in time, right? So you kind of have to interpolate where that other person is one message behind, right? So if you are here and the other person, if both of you are actually here, as far as you're concerned, the other player might be here from what you observe. So you are kind of interpolating these two frames for the other player, and you're interpolating these two frames for yourself, right? I interpolate at my job every day. Interpolation are lies. Way to make it political, dude. Anyway, well, interpolation is in this case is more of a prediction that might be incorrect, and even though that's not a lie, it might not be an objective truth. In the previous article, the behavior of the server was described was very simple. It read client inputs, update the game state, and sent it back to the client. When more than one client is connected, though, the main server loop is somewhat different. In this scenario, several clients might be sending inputs simultaneously at a fast pace. And the thing is, I have probably written down how all of this should be done, right? So if we go back to where I found this, so it's going to be 2025-04-20. Here. This is probably written here already how this is done, right? So let me read through my own notes rather than reading that article, even though it was over a year since I wrote this. When the server starts up, store the current time on the server. This way, there is always a possibility to see how long the server's been running for, as well as sending the current timestamp of the server to the client if that should be needed. When the client connects to the server timestamp should be sent to the client. When the client issues a command, this command can be applied locally and it can be sent to the server along with a packet number. Since both the client and the server have the same command execution time, this will be deterministic. This means issuing a single move east command would result in both the client and the server moving the player sprite eastward for the duration of the command execution time. Assuming the player has a sprite associated with it at x0, y0, and the player sends the north command to the server, the following events should take place. Create the payload for the server. The server knows entity ID 2 is the player. Let P equals command north packet ID 0. Add the payload to the outgoing queue. Send the payload to the server. Start moving the entity number 2 northward for a duration of command execution time. 5. Store the state in the local state buffer. The state buffer contains a list of player states and commands. The client might render at 60 frames per second, however, the network publishing might happen 20 times per second. The input sample rate doesn't have to match the command execution time or the render frequency, but it can run at its own interval. The but word there is kind of weird. The only consistent timing here is command execution. On the server, receive a message from the client, apply the client input to the entity in the world and perform the command for the given duration. Send state back to the client. On the client, receive an ACK message from the server with the packet ID and the position. rewind the state to the one that was the one that has the same packet ID, replay all commands locally up to that point and interpolate the player current position to that of the final result. I can't believe I've had this all along. I read this a year ago for something that I never did. And here we are, right? One thing that is a little bit confusing by this, which I'm gonna catch up on, I see I'm missing something here, which is the command execution time. This hasn't been specified what this actually means, but it will probably be specified here. So command execution time is probably something like a command frequency, right, of 20 milliseconds. So every command executes exactly for 20 milliseconds, something like that, probably. All right, but let's look at this thing, right? Hello, I'm outside guy. How do you predict those positions accurately? I think this will make sense once we codify this. But if we think about it like this, if every command executes for a duration of 20 milliseconds, that means if you say go north, you will go north for 20 milliseconds, right? If we've established that, and when you connect to the server will tell you, welcome, my current time is midnight. It's exactly 0000, right? So when you send north, you know how much time has passed since you connected to the server, because you get the server connection time. So you tell the server, I'm going north at this moment in time with this packet number. The server will get that. Actually, it will get that at its own time. I'm getting a little bit confused by this, but we're going to clarify this shortly. The server gets going north, plays that command for 20 milliseconds, which moves the player north for 20 milliseconds. It will send the act to the player. I'm doing good, Amatsu. I'm doing good. I'm boiling a little bit, but I'm doing good, right? What was I saying again? Okay, let's write. We're gonna write this down in code instead. This is a little bit confusing because the command execution time isn't defined in here, but I do think the command execution time is a fixed time unit that every command should execute for, right? So let's have a look. Let's have a look at it, right? In the previous article, the behavior of the server described was pretty simple. It read inputs, updated the game state, sent it back to the client. When more than one client is connected, though, the main server loop is somewhat different. In this scenario, several clients might be sending inputs simultaneously at a fast pace, as fast as the player can issue commands, but be it pressing arrow keys, moving the mouse, or clicking the screen, updating the game world every time inputs are received for each client and then broadcasting the game state would consume too much CPU and bandwidth. A better approach is to queue the client inputs as they are received without any processing. Instead, the game world is updated periodically at low frequency, for example, 10 times per second. The delay between every update, 100 milliseconds in this case, is called the time step. In every update loop iteration, all the unprocessed client inputs are applied. All the unprocessed client inputs are applied, possibly in smaller time increments than the time step, to make physics more predictable, and the new game state is broadcast to the client. In summary, the game world updates independently of the presence and amount of client inputs at a predictable rate. So every client has an output queue that is sent to the server at a given interval. And I think this is what we already do with our client's input. Here. So we call update inputs with some frequency. No, wait. This input is sent somewhere. And let's look at the net. Here we go, right? So we are aggregating input. Okay, this should build up a queue instead, right? This should build up a series of messages instead of just one. So this should contain something like at midnight we send north, and then at as one input, right? And then you would have a second one, right? Which could be I guess we could just write it as that, right? So we have, and that's packet 1, that's packet 2. So we are sending a line of or a queue of inputs to the server with some relevant timestamps. So the server can play these inputs back from these timestamps, right? But again, I need to read through this. I might be telling you a porcupine, right? And I don't want to do that, at least not unintentionally. I want to intentionally lie to you, but you know. Anyway, so but an image is forming at least, right? Okay, so a better approach is to queue the client inputs that are received. Oh yeah, and we are sending this for sleep time every 50 milliseconds, right? So every 50 milliseconds, we are sending our input queue, right, to the server, which is more than 10 times per second, but still, it's 20 times per second. This delay between every update, 100 milliseconds in this case, is called the time step. In every update loop iteration, all the unprocessed client input is applied, possibly in smaller time increments than the time step, to make physics more predictable, and the game state is broadcast to the client. In summary, the game state updates independently of the presence and amount of client inputs at a predictable rate. From the point of view of the client, this approach works as smoothly as before. Client-side prediction works independently of the update delay, so clearly also works under predictable, if relatively infrequent, state updates. However, since the game state is broadcast at a low frequency, continue with example every 100 milliseconds. The client... Yes. The client has very sparse information about the other entities that may be moving throughout the world. A first implementation would update the position of other characters when it receives state updates. This immediately leads to a very choppy movement that is discrete time jumps every 100 milliseconds instead of a smooth movement. And this is where interpolation is going to come in, right? So this is when we get the state of the other players, that has to contain the time state, the timestamp, so we can constantly be interpolating between the previous state and the current state, right? Depending on the type of game you're developing, there are many ways to deal with this. In general, the more predictable your game entities are, the easier it is to get it right. Suppose you're making a car racing game. A car that goes really fast is pretty predictable. For example, it's running at 100 meters per second. A second later, it will be roughly 100 meters ahead of where it started. While roughly during that second, the car could have accelerated or decelerated a bit, turned to the right or to the left a bit. The key word here is a bit. The maneuverability of a car is such that at high speeds, its position at any point in time is highly dependent on its previous position, speed and direction, regardless of what the player actually does. In other words, a racing car can't do a 180 turn instantly. It can, but it's not healthy for the driver or the car. How does this work with the server that sends updates every 100 milliseconds? The client receives authoritative speed and heading for every competing car. For the next 100 milliseconds, it won't receive any new information, but it will still need to show them running. The simplest thing to do is assume the car's heading and acceleration will remain constant during that 100 millisecond and run the car physics locally with those parameters. Then 100 milliseconds later, when the server updates arrive, the car position is corrected. I think this is going to come back to what I bastardized with the frame history. I think we're going to be observing the world in the past, right? The correction can be big or relatively small depending on a lot of factors. If the player does keep the car on a straight line and doesn't change the car speed, the predicted position will be exactly like the corrected position. On the other hand, if the player crashes against something, the predicted position will be extremely wrong. Note that dead reckoning can be applied to low speed situations, battleship, for example. In fact, the term dead reckoning has its origin in marine navigation. Entity interpolation, right? Now, if you're gonna go by like modern networking for games and you're gonna handle a lot of connections, then you are looking at eBPF, right? You're basically writing your net code in the kernel, right? Anyway, you can't just update player position when the server sends authoritative data. All right, anyway. There are some situations where dead reckoning can't be applied at all. In particular, all scenarios where the player's direction and speed can change instantly. For example, in a 3D shooter, players usually run, stop, turn corners at very high speeds, making dead reckoning essentially useless, as positions and speeds can no longer be predicted from previous data. You can't just update player position when the server sends authoritative data. You get players who teleport short distances every 100 milliseconds, making the game unplayable. And it might be in this blog where it mentions that if you were to fire, we're comparing the game state at the server time when you fired. You have the server. We're comparing the game world at that moment in time, which is why it looks like you can shoot through walls sometimes, right? You shoot a player, but when you press the fire button and the player, that moment in time, the player might not have been behind the wall, right? Isn't there a good networking reference somewhere in C code for ID software Quake? No idea. Will we learn about eBPF? No, you will not. You have to go. You have to go and read. eBPF millions of connections. You have to go and read this. There are some situations where it doesn't work. You can't just update player position when the server sends authoritative data. You get players to teleport short distance every 100 milliseconds, making the game unplayable. What you do have is authoritative position data every 100 milliseconds. The trick is how to show the player what happens in between. All right. So we know if you push the fire button at a given timestamp, the server can check what the time was when you pushed the fire and then look at the state on the server to decide whether you hit or not, right? Anyway, the way what you do have is authoritative position data every 100 milliseconds. The trick is to show is how to show the player what happens in between. The key to the solution is to show the other player in the past relative to user's player. Say you receive position data at T1000. You already received data at T900, so you know where the player was at T900 and T1000. So from 900, so from 1000 to 1100, you show what the player did from 900 to 1000. Right, yeah, so you're one frame behind, right? I don't like this at all. Other players should see what the server knows at all times. So you live in a world without latency then, Verse Warrior, right? There's an alternative to interpolation. You send the velocity and whatever else it needs to predict what's coming next. But then, again, that wouldn't work if you... Well, it would work if you can deterministically do the physics on the client and the server, right? Which I guess you're going to need anyway, right? This way, you're always showing the user's actual movement data, except you're showing it 100 milliseconds late, right? But either way, you are never going to know what the other player does the moment they do it, right? Because that's a world without latency, okay? Hello, Trash. How you doing? How do you use AI as part of your daily coding work? I usually only use it as part of talking about it when people ask questions about it, right? I think most people here are highly skilled coders. Yeah, they like to pretend to be, but I don't see a lot of code. I see a lot of opinions and very little actual code though, Trash. So I don't know. I might not need AI for coding. I think it's about needing AI. I think it's about choice. Also, I think it removes a bit of the enjoyment of problem solving. Absolutely. Welcome to box one. Still, development is fast, which is good for any company. Thoughts? Yes, many. I will give you a short summary, Trash, that leads to a lot of friction in people's brains, but I'm gonna tell you anyway, right? Let me see if I can just do this summary without starting up the conversation. Okay. There are programmers who like to program the way I do. We write syntax, we solve problems by thinking about them, we enjoy the journey, we enjoy the process, and the end result is not necessarily the most important thing. We are the artisanal, handcrafting programmers of yore, right? Then there are programmers who don't care about the journey, they only care about the result. They probably never wanted to be programmers in the first place, because if they enjoyed that programming, that level of programming, they would be in box 1, not box 2, right? And where you get friction is when box 1 and box 2 talk to each other and they think about each other as programmers, not as different kinds of programs. Those are my 2 cents, right? Syntax enjoyers. I love both. No, you don't. I like this quote by Torvalds. Most good programmers do programming not because they expect to get paid or get adulation by the public, because it's fun to program. There you go, right? Are these interesting pop renditions performed by one and the same, or is it some kind of ragtag collection of stream background? I'll send you a link, VMT, if you want. If you remind me. I can't answer that. Right. Okay, so we are rendering the world one frame in the past, right? Which obviously means that your own input could feel sluggish, right? We might not be friends, VMT. Let me adjust that. Is that you? Okay. There you go. Say you receive position data at T1000, you already received it at 900, so you know the player was at 900, and thousands from 1000 to 1100, you show what the other player did from 900 to 1000, right? So T is probably server time in milliseconds. Time since the server started in milliseconds, right? And now we're friends. Oh man, that's amazing. Let me just say it, lol, friendship. There we go. Yep, that works. Okay, let me drop this into your thing. Where are you? How do I do this? I think this is the one. There we go, right? Copy link. I think that's it, right? Yeah, that looks it. Problem is player models are present behind wall of the client. I play a game called Rainbow Six and quickly get peeked and die before even seeing the enemy. I'm thinking there might be a problem with the interpolation of the game. It's so quick, the servers are not ready for it. I don't know how it works, Gab, but this is why I say I think what the server does is when you press fire, when you click the mouse button to fire, that is timestamped. And the server will look at the state at that moment in time. And if you were out of cover at that instant, then you are hit. I think that's how it works, right? Done job hunting? Did you find anything interesting there, right? I don't have the brain bandwidth to take in what you're saying, Suji. I'll just tell you right now, because this and the other conversations is taking up all of my brain space. All right. What you have is authority position data every 100 milliseconds, right? All right, so we've done this. Let's open this thing up and have a look. Okay, so it doesn't include like the timestamp here, so I don't know, right? I'm not sure what the V value represents. That might be velocity. If we have velocity, we can do interpolation. Visual position interpolated from past authority position. Okay, so that kind of makes sense, right? I think the only way, like I said, at the moment, you because you live in a world of latency. You have to accept latency. There are different ways of dealing with it, but there is no reality where there is multiplayer across a network with zero latency, right? I mean, like, even your mouse has latency, right? Mine doesn't because it's new and shiny, right? Okay. The position data used to interpolate from blah depends on the game. Okay. Depends on the game. Interpolation usually works well enough. If it doesn't, you can have the server send more detailed movement data with each update. For example, a sequence of straight segment followed by the player's position sampled every 10 milliseconds, which look better when interpolated. You don't need to send 10 times more data since you're sending deltas for small movements. The format on the wire can be heavily optimized for this particular case. Note that using this technique, every player sees a slightly different rendering of the game world because each player sees itself in the present, but sees other entities in the past. Even for a fast-paced game, however, seeing other entities with 100 milliseconds isn't generally noticeable, right? I think this might not feel true for FPSs, right? 100 milliseconds in an FPS is probably the difference between life and also life because it's a game where you don't actually die. There are exceptions when you need a lot of spatial and temporal accuracy, such as when a player shoots another player. Okay, here we go. Since the other players are seen in the past, you're aiming with a 100 millisecond delay. That is, you're shooting where your target was 100 milliseconds ago. We'll deal with this in the next article. So I guess that's what you can do then, right? You can offset. If you're shooting where the player was 100 milliseconds ago, then you either have to you have to look at the game state 100 milliseconds ago when you apply this. I think that's the simple mind of it, right? My mouse is wired, so check me. Oh, you got me now. Damn it. New shiny and with a firmware update. Correct. But it stopped conking out after the firmware update. It actually became usable. So I was about to get rid of this thing, but I didn't. I wasn't going to get rid of it. I was just going to accept it as sucked and just be miserable for the rest of my computer life. There are exceptions, right? In client-server environment with an authoritative server, infrequent updates and network delay, you must give players the illusion of continuity and smooth movement. In part 2 of the series, we explored a way to show user-controlled player movement in real time using client-side prediction and server reconciliation. This ensures user input has an immediate effect on the local player, removing a delay that would render the game unplayable. Other entities are still a problem. However, since this article, we explored 2 ways of dealing with them. In the first one, dead reckoning applies to a certain kind of simulation where entity position can be acceptably estimated from previous entity data, such as position, speed, and acceleration. This approach fails when these conditions aren't met. The second one, entity interpolation, doesn't predict future position at all. It uses only real entity data provided by the server, thus showing the other entities slightly delayed in time. The net effect is that the user player is seen in the present and the other entities are seen in the past. This usually creates an incredibly seamless experience. However, if nothing else is done, the illusion breaks down when an event needs a high spatial and temporal accuracy, such as shooting at a moving target. The position where client 2 renders client 1 doesn't match the server nor client 1's position, so headshots become impossible. Skill issue. Since no game is complete without headshots, we'll deal with this issue in the next article. Lag compensation. Okay, if you go to the demo, you can see the jitter when you make the delay tick bad enough. You think the thing I do not get from the article you're reading is how does the not jitter run like crazy when we always need to correct our guesses? Yeah, there's at the end of this, there's a live demo, or we can read it in Korean. There's a live demo where we can test this stuff out. I think this leads to the live demo. Yeah. So this is the last part of this. The previous 3 articles explain client-server game architecture, which can be summarized as follows. Server gets input from all clients with timestamp. Server processes inputs and updates world status. Server sends regular world snapshots to all clients. Client sends input and simulates their effect locally. Client gets world updates and syncs predicted state to authoritative state. Interpolates known past states for other entities. From a player's point of view, this has 2 important consequences. Player sees himself in the present, player sees other entities in the past. This situation is generally fine, but it's quite problematic for very time and space sensitive events. For example, shooting your enemy in the head. Lag compensation. if you're aiming perfectly at the target's head with your sniper rifle, your shot is a shot you can't miss, but you miss. Why does this happen? Because the client server architecture explained before, you're aiming at where the enemy's head was 100 milliseconds before you shot, not when you shot. In a way, it's like playing in a universe where the speed of light is really, really slow. You're aiming at the past position of your enemy, but they're long gone by the time you squeeze the trigger. Fortunately, there's a relatively simple solution for this, which is also pleasant for most players most of the time, with one exception discussed below. Here's how it works. When you shoot, client sends this event to the server with full information, the exact timestamp of your shot and the exact aim of the weapon. So I guess this could be cheated, right? You could have a compensation which gives you like an additional frame or whatever, right? So when you aim and you shoot, it's not going to look at the previous state or like 100 milliseconds in the past. It can look maybe 200 milliseconds in the past, right? Although whether that's advantageous or not, I don't know, right? Here's a crucial step. Since the server gets all the input with timestamps, and this is what I'm saying, you could fob the timestamp, right? It can authoritatively reconstruct the world at any instant in the past. In particular, it can reconstruct the world exactly as it looked like to any client at any point in time. This means the server can know exactly what was on your weapon sight the instant you shot. It was the past position of your enemy's head, but the server knows it was the position of the head in your present. The server processes the shot at that point in time and updates the clients. And everyone is happy. The server is happy because it's the server. It's always happy. You're happy because you were aiming at your enemy's head and shot. You got a rewarding headshot. The enemy may be the only one not entirely happy, but they were standing still when they got shot. It's their fault, right? If they were moving, you're a really awesome sniper. But what if they were in an open position, got behind a wall, and then got shot a fraction second later when they thought they were safe? And I'm guessing this is what Gab was talking about, right? That can happen. That's the trade-off you make, because you shoot at the enemy in the past. They may still be shot up. They may still be shot up to a few milliseconds after they took cover, right? You could ignore the speed of the projectile and make it almost instant. So the lag that you have is traded off by the time it takes for the physical projectile to travel. Camera, come on, man. So then we're all happy. I think that doesn't really matter. If your bullet has an actual speed to travel or not, that's the same for everyone. So your weapon has an exit velocity, or your bullet has a velocity, right? I think the outcome is still the same, right? If a bullet travels some time before it hits a target or not, you are still looking at the world at that moment in time for when that happened, right? The enemy might be the one who's not happy, but if they're in an open position, that can happen. That's the trade-off you make, because you shoot at him in the past, it must still be shot up a few seconds. Okay. But it is somewhat unfair, but it's the most agreeable solution for everyone involved. It would be much worse to miss an unmissable shot. This ends my series on fast-paced multiplayer. This kind of thing is clearly tricky to get right, but with a clear conceptual understanding about what's going on, it's not exceedingly difficult. Although the audience of the articles were game developers, I found another group of interested readers, gamers. From a gamer's point of view, it's interesting to understand why some things happen the way they happen, right? All right. Yeah, I think a lot of it is just visual, right? Okay, quick break, because my hair is caught in my headphones, to stretch my legs a little bit. Stretch! All right, and a quick wee, and then we're gonna write this up and start implementing it.
Okay. Mistakes have been made. I'm sorry. I have completely lost track of time and I need to go and eat some food. But I might do a second stream today. I don't know. Because this is really exciting stuff and this is all that we need. So we're going to do this. But until then, I think I'm going to have to pass you on to someone else because I need to go and eat some food. Lest I will perish. I can't be done messing with this thing, right? Anyway, you guys have been great. Thank you for hanging out. I will possibly be back in like half an hour or so. Let's go and eat some food. Then we're going to implement this thing because I think we have all the information that we need for this. And then maybe if we're lucky duckies, we can actually see some of this stuff moving around. All right. Thank you so much for watching. And I hope you have a good rest of your day.